Public traffic, Signal 102.
Signal 102, confirm established.
Affirmative.
Thank you, contact tower 119.4, good night.
119.4, 102, good night.
Iberia 3575, proceed after Soleno, direct Delta.
After Soleno, Delta, Iberia 3575.
France 2039, direct Sydney.
Direct Sydney, France 2039.
Tirol 78 Victor, contact Queen 13435, servus.
13435, 78 Victor, servus.
Tirol 256 Kilo, contact Queen Leader 133, decimal 8, servus.
In radar, good evening, CSA 607 for heading 030.
2607, good evening, identified, campus level 160.
Contact level 160, CSA 607.
Austin 459, 2700, climbing 5000.
Austin 459, guten Abend, identified, campflight level 240. 78 Victor, direkt Rattenberg.
Direkt Rattenberg, Tirol 78 Victor, Dankeschön.
Guten Abend, Austin 180 Sierra, out of 220, descending 150.
Austin 180 Sierra, guten Abend, information Whiskey, expect a less 16, no speed.
Meet. I'm welcoming you live from wherever you're joining us. I know that we have registrations from all around the world. It's morning here in Europe, it's evening in Asia, and it's probably nighttime in the Americas. And I'm not sure we're gonna have live viewers here, but I will be excited. Today is really a special day for me, and today is a special day for all of us. We would normally all be in Madrid, but again, this year is different. This year, Madrid World ATM Congress is going to be in October this year, and I'm very much looking forward being there and meeting you all. This year is different. We decided to host another Frequentis Connect session as we had last year. We had, as you remember, we had a very successful Frequentis Connect session last year, and we are now hosting this again. We have now we've got ourselves 5 sessions ahead of us. We start now with the first session, and that's going to be about digital platforms. 2021 is certainly different for all of us, and we all looking forward to changing to the change that is going to be better for aviation, better for the whole economies. How does the new normal look like for us? How is it changed? I mean, for the traffic, we all know that it's nowhere near where it should be, but there are positive signs ahead of us. There is, for instance, in the US, the CDC just recently announced that people can meet in private without masks and without social distancing. This is really exciting news. Or I've seen pictures from friends from Australia, from New Zealand, where things are really, really normal. Still, we have to be careful in aviation, and we have to be cautious in travel, but it's also about us to prepare now for the new future, for the new normal. How's it going to be, this new normal? It's a lot about digitalization. We will see the advance of digital systems, digital towers, digital and virtual centers, but it's also about climate change. Going forward, I'm sure there will be a lot more focus on climate change, and we are working on things to optimize traffic, to ensure emissions are reduced, and also that unnecessary structures are no longer built. So jumping into the first session, but before that, I would like to explain how you're going to interact with us. So there is the YouTube chat, and I'm just now looking at the chat if there's anything going on, and right now I see a few postings there, so I hope you get yourself involved, get excited, post some things in your chat. We have about 500 registrations for this session now, and also for the rest of the day we have close to 2,000 registrations in total. So everybody who is here and wants to get involved, please put that in the chat. And I'm really looking forward looking at the chat. Post from where you're joining, post where you are, and let us know that you are joining here and that you're getting excited. The second way of interacting, if you don't prefer the chat, we have opened up an email address, and it's also in the chat, invitations@frequentis.com, where you can post questions. And since this whole thing is a live event, we are making sure we try to answer all these questions during the stream. So let's get going with the first session. This is going to be about digital platforms, the story about unified situation awareness, managed services in the hybrid cloud, and I have 3 exciting speakers here. The first speaker is Thomas Haschberger. He's the VP of Technology for the Frequentis Group. So he's basically the head of product, and you could even call him the CTO of Frequentis ATM. Then I have Marian Mitev, the Strategic Product Manager for ATM Networks. And I have also Jonas Haber, Customer Service Manager, who will talk about managed services. So I really like this session because it goes into mainstream IT and how this moves actually into the ATM world, where it's all about safety. So, Thomas, are you ready? Over to you.
Okay, thank you, Markus. Very warm welcome from my side. Hello from Vienna. As Markus already introduced, the next session is about digital platforms, a story about unified situational awareness, managed services, and hybrid cloud. Frequentis ATM portfolio, we started the journey approximately 3-4 years ago. Breaking up the silos is basically what we started. With our growing portfolio from VCS to MHS, from surveillance to tower automation and virtualization, including the Comsoft portfolio, including the Atrix portfolio. This allowed us to look closer at the integration of these applications to the benefit of the air traffic controllers, the users, but also to the operation of such systems. And at the same time, we saw the advantage of upcoming new technologies, data centers, virtualization, the cloud technologies, basically. So we came up with 3 principles for our product portfolio. The architecture shall be cloud ready, the applications shall be split in services, and open interfaces shall allow us to interconnect and integrate our own applications, but also with other ATM applications. If we have a quick walkthrough here, have a look at the architecture. Starts with the IT infrastructure network virtualization, where we decided already several years ago for the Docker virtualization. Then a middleware framework on top of that for orchestration of the services, for the monitoring, logging, and so on. The applications in the back end and the applications for the front end. Application split and services, another important topic. We said breaking up the silos means also no monoliths in this area anymore. So after the horizontal structure in the architecture you see on the left side, we started to break up also our applications. And also important to break up the back end from the front end to have 2 possibilities. One is physically the front end separated from the back end for virtual center or other net-centric deployments of any kind. And of course to allow more flexibility on the HMI side. The buzzword here is integrated controller working position. Many of you know that. So also here there are several reasons to go into this direction. And last but not least, open interfaces. Use standard logging and monitoring mechanism like SNMP, Prometheus, the Docker API to orchestrate the services, Swim to add all the interconnectivity in the ATM world, and finally allow different front ends to access the backend services. So also go here into the direction for open interfaces, which gives our customers then more flexibility on this side, and have not one HMI beside the other without any to integrate them. So these were basically the principles we applied to our product portfolio, and as I said, we started that already several years ago, and do that with our growing product portfolio step by step. Most importantly, also for our voice communication system with the release 10, where you hear later more about that, but also for all the other applications which allow us now to deliver integrated solutions. The middleware framework, as you can see also in the left side on the slide, here we created a bridge from the standard COTS IT cloud infrastructure to our products. And if you have a closer look at this, so what did we do here? The framework allows us to deploy all our products, be it VoiceCom, be it an automation product, a surveillance product, or other things, together with integrated system management, together with an overall monitoring of the complete system, and have a unified logging configuration monitoring for that. In addition, we make sure that all the typical safety aspects are covered, ED 153 compliance, COTS assurance for all the standard COTS IT elements which are used in this framework as well, or below in the infrastructure. So make here a good baseline then to start deploying the application services which are compliant, ED 153 compliant then anyway. We make use of standard IT technologies here like Linux, Docker virtualization, I mentioned already SNMP and Prometheus monitoring interfaces, Elk Stack for logging. So there is a low vendor lock-in part of that, or coming with that, but together with some add-ons like synchronization for the missions where the role of controller working position can change from night to day, or sector to A to sector B, synchronized for all the applications running on top of it. Also something which is important here and part of the mainstream IT technologies today, and we miss it a bit in the ATM sector, is everything around continuous integration, continuous deployment. With such a setup, we allow also our customers to go into that direction together with test automation, and also here we can provide you with our frameworks to have a test automation running whenever you want it, giving you a big coverage of any changes. And the target in the future here is, of course, apply smaller changes more often and not wait many years before a new system is deployed. In the middle, you see the SWIM topic coming into the picture. Of course, open connectivity, exchange data in the ATM world is a very important part, and of course covered here in our framework as well. Service registry, API management, security gateways, All this is available as Mosaic Swim. And you will hear later today also about this in much more detail. And yeah, last but not least, this framework allows in a net-centric deployment to help our customers now in the deployment of virtual center scenarios. So wherever these data centers are located, wherever controller working positions are located, be it now an ACC virtual center connection, or maybe also in the future with remote towers, a tower center, all these deployments can be supported and yeah, managed, monitored, configured by you in the same way. Using all this standard IT mechanism now to get into the new technologies, become cloud ready, of course, allows also you as a customer then to use this know-how which is existing everywhere around cloud technologies, even outsource the operation of such data centers, and hopefully with that also to save cost on your side. And this in difference to the past, where we had very specific ATM systems side by side in every ANSP location, basically. So to summarize, that's what we built as the digital platform for our ATM portfolio in the future, and which we want to make more use for. It is currently in first deployments in Europe, starting to evolve. First customers use our framework already to deploy their applications, integrate them in a tower environment. With that, I would like to hand over to my colleagues. We will hear now about the two successful implementations, two examples for these new technologies in the ATM area. First, about the ATM-grade network management and monitoring to allow these net-centric deployments, and second, then UTM, software as a service implementation for Avinor, where we really are at using leading-edge cloud technologies to support the UTM area here. Okay, this was it from my side. I hope you enjoyed it, and with that I would like to hand over to my colleague for the networks part. Thank you.
Thank you, Thomas. Good morning from my side. Good morning from Vienna. I will be speaking today about the unified network management system deployed in ATM-grade networks, which benefits brings, and at the end how the overall network situational awareness can be increased. So let's start with the challenge. So in traditional networking, we have different applications which are deployed with including different monitoring tools, including alarming and fault management, and they already have dedicated network infrastructure which are strongly coupled to them. With this approach, with the application-specific network silos, and with responsibility spread over different departments and units within one organization, this approach is very complex, and which certainly leads to low situational awareness. The complexity, also as communication between distributed teams in one organization is not always effective as it supposed to be. This directly leads to higher response and resolution times, which certainly decreases the safety of operations at the end. Therefore, just like the IP migration follows and brings the benefits, business benefits of integrating different application-specific network silos within one IP single network, which is serving multiple applications from different vendors and different technologies, the same approach is also here. We have the unified network management system, which is comprising all the network monitoring tools from the different applications within one single homogeneous system under one umbrella management system, which certainly helps to increase the operational awareness to the highest level. With the end-to-end service view, the network engineers have the possibility to immediately detect the failures and faults in the networks, and also can proactively act to prevent further failures and downtimes in the network, and this is increasing the productivity and in effectivity in the network, and later we will see an example, how does it look like with the real service example, and all of this functionalities at the end are increasing the safety of operations. Okay, that was those were the challenges. Let's now see what's there, what's in the network management system, in this end-to-end system and solution. So let's focus first on in the middle. With the dark blue, we have the core modules of system. So it starts with the dashboards, including different tools for reporting and analytics. Then going down, we have the fault management, which includes functionalities for alarming, root cause analysis, tools for fault investigations, and so on. Next to it, we have the configuration management, and this is about to enforce different configuration policies, config backups, alarming if certain configuration policy is being violated, and so on. The performance management module next is about capacity management. It's about keeping the KPIs and SLAs in view. It's about network availability, but also service availability. Going a bit down in the security management model, it's about auditing tools. It's about data confidentiality. There we have also functionalities for user and role management, also including the full user audit history. The automatic network discovery jobs are located in the next model, in the inventory discovery, and automatic recognition of vulnerabilities is in the last model here, also including the device lifetime, or so-called end-of-life management. Also, we have all the outputs data, which is coming out of these modules, are kept and stored in the database, which is replicated in different data centers, which can be on the different geographical locations. So also keeping in mind the end-to-end design of such solution, as it's supposed to be in the ATM domain. And one layer below, we have the remote agents, remote models, as it's called here. So basically, those are the agents which are used to collect the data from different data sources, and we have here the monitor elements, which are in fact the data sources, where the data is collected by the agents, it's polled, and then it's pushed to the core modules in the unified network management system, and depending on the functionality, the data is processed, and we have the output data in the dashboard, which is also including and coming with different views and different analysis. Some example we will also have, we will see a bit later. And also this data can be also provided from the node-bound interface through different interfaces, can be provided to other systems like ticketing system, emails, SMSs, and so on. Okay, then let's see, I've mentioned the end-to-end service view, which is very important and is coming as the main benefit out of this solution. So in this case, we have a real example of radio frequency service. We have the voice communication system deployed at a controller working position, and then on the other side we have 3 different radios spread and deployed on different sites. So we have the main standby and we have tertiary radio. And then we have a lot of systems and applications in between. So we have the remote modules with blue, which are deployed next to the application. Then we have the on the access points, we have different gateways, which are also coming with their monitoring tools and also providing data. Then we have different IT assets, routers and switches. And we have then 3 available networks in between, which can be utilized for this specific service. And we can see in this example, we have the one of the radios, the second transceiver is down currently, and the one of the networks, in this case the satellite network, is also not available due to some blackout events. And in this case, what we correlate all this data which we are collecting from different monitoring tools, we are providing into one logical view, as you can see with the blue ribbon. That means for the engineer, the immediate information which is provided is this overall service status, which is now with amber color, which gives the immediate indication that this service is available, is running, but something is wrong. So from this view, the network engineer can immediately detect where's the problem is in the network and in one of the transceivers, and can immediately act and prevent further failures. So this is the high level view. Then it can be drilled down to different systems, to different elements, like it's shown in the example. And then imagine this view. It also can be spread for many services. It can be also for different data services, different radar services, voice services, and so on. We have a bit later one example of services, how many services we have deployed in real deployment, in real environment with our customer. But just imagine now, if this view doesn't exist, just imagine how big is the effort to have a look in different monitoring tools all the time and to correlate all this data, which at the end is based on the experience of the network engineers, how they can use this data, use this information from different tools and react. And the productivity is definitely very low in this case. The other benefit which is coming in this from out of this solution is it's a different view, which for this purpose we are using the active probing system of our NetBroker solution. So to provide very important information from the network to the network management system. So we have the active probing system, which is deployed on the network edges. And there are different, you can see different blinking lines in between the edges, which are actually different services provisioned with different adjustable parameters and different KPIs, because not every service in the network has the same network requirements and same KPIs or same accuracy of this data. For example, voice service as most critical has the most accurate data to be provided from the network. And some data services, for example, don't need this accuracy and those certain KPIs like the voice. And at the end, the active probing system is measuring the data continuously, and it's providing all this data to the active, to the blue layer, which is actually the NetBroker solution. This data is then being processed by the NetBroker, and it's converted into an ATM grade visualization. And this is the view what the network engineer will see, keeping in mind his operational needs. So on the left side, you can see a geographical map with different points deployed in the network. So we have one ACC and we have 2 remote sites with different traffic types, which is being exchanged between these endpoints. On the right side, you can see the notification of these network statuses, which are mapped to the actual state of the network links. So that means we can see between point 1 and point 2, we have network link which is with green color. That's immediate indication for the network engineer that this link is up and running, it's stable, everything is supposed to be like it should be. On the right side, we can see this notification with green, everything is fine. Once the brownout event occurs, the link is immediately turning from green to orange and following with the warning sign. And we can see that also between the point 1 and point 2. And also we can see the notification, immediate notification on the right side in the status bar. So we have the orange events with brownout. You can see at the top we have multiple brownout detects. That means that the events, that means the link is going up and down. It's not stable. In the second example, we have a longer brownout event, which can be further then analyzed by the network engineer. So all this data can be accessed and can be used for reporting and analysis in a later stage. And then between the endpoints 1 and 3, we have one example when the blackout event completely occurs and completely occur at this link. So the link is now turned red with the also with the following warning sign, and that's an immediate indication for the network engineer that something bad is going on with this link. And on the right side, again in the right view, we can immediately see down this event with red, which again can be accessed later and analyzed further. But this immediate view gives the engineers the view which can they immediately react and take actions. And all of this data which are provided and visualized here can also be used for example, for voice traffic to be converted into mean opinion score values ranging from 1 to 5, which is giving again immediate indication for the network engineers that something is how the voice traffic in the network is assessed, so they can accordingly take measures upon this. Okay, so I've mentioned before also the real deployment. So we have deployed such unified network management solution with our customer in Brazil. So the customer had a big challenge to maintain different systems from different vendors, different technologies also in place, and keeping in mind that the size of Brazil is twice as bigger as the size of Europe. And you can see also the figures on the left side. It's quite, you can imagine the complexity and the effort to maintain those systems is quite big, and it's also quite expensive. This solution was deployed in only one flight information region out of 5, which also gives the indication of the scalability of such solution, which can be adjusted according to the customer needs and plans. What we did on the right side, we can see the figures. So currently in only one flight information region where the system is active and running in environment of the customer, we have more than 50 different monitoring links coming from different technologies which are constantly under monitoring. We have more than 750 services, different types of services, voice, data, video services, which are constantly under monitoring in this end-to-end service view, as we've seen in the previous example. And imagine how useful and how beneficial is this for the customer to have all these services listed in this logical view and can immediately spot the performance of such services and can immediately take actions upon this. And now imagine how much was the effort before such system for keeping and monitoring this huge amount of measurements and services. Then we have different types of devices, different IT assets, routers, switches, firewalls, servers, modems in the network in this region. So more than 2,000 devices for monitoring, and amazingly more than 90,000 measurement streams are constantly feeding this system from these integrated tools and feeding the systems and providing data, which then is correlated into logical views and is providing this productivity and effectivity, which is come as as one of the main benefits out of this system. The achievement you can read in the customer quote from Captain Carlos Paez, what we did and what was the satisfaction of the customer. Then moving to the last slide to summarize what what was this about? So we are providing the ATM grade layer powered by our NetBroker solution. This is with the light blue layer which is brokering between the non-ATM grade infrastructure and ATM grade applications, and it's providing the missing intelligence in the commercial networks in order to become ATM grade ones. Above the ATM applications, we have now the unified network management system, which is comprising all the different monitoring tools which are coming along with this application silos, and it's comprising under one unified and homogeneous system. With the end-to-end service view, we are correlating all the data. We are collecting and correlating all the data into logical views for the services, as we've seen, which is definitely increasing the safety and effectivity of operations. The network management solution comes with the ATM grade design and functionalities, and following also the integration concept to scale and in the future according to the customer needs and plans. And we've seen that with our real deployment. The solution is deployed only in one flight information region and also will be deployed in the next phases and rolled out in the next flight information regions in the future. So all of this is bringing four major takeaways out of this. So this solution is providing the highest situational awareness by comprising and all the different monitoring tools into a single homogeneous system. This for sure is reducing the operational cost to maintain these individual monitoring tools, and also reduces the total cost of ownership for owning such a unified system. The logical service view and logical and end-to-end service views are giving the needed proactivity for the network engineers to detect immediately these network failures, but also to actively prevent, to minimize and completely prevent further failures and downtimes in the network. And all of these functionalities, of course, are provided with by a safe and resilient solutions, which is as is expected in the air traffic management industry, leaving the commercial solutions behind in the enterprise segment. So that was my demonstration today. I'm looking forward. Thank you for your attention. I'm looking forward for the Q&A session a bit later. Before that, we have also coming very interesting topic and very interesting demonstration from my colleague Janos. It's about UTM as a service. Stay tuned. Thank you.
Good morning, good afternoon, or good evening, and thank you very much, Marian. During my presentation, just a short reminder, during my presentation, if you have any questions, comments, please feel free to write them down in our YouTube chat. We'll make sure to answer as many as possible. Let's start. During the past years, we observe a transition from more traditional on-premises IT solutions to a more and more digital-oriented cloud solutions. Frequentis is already providing, and for this, managed services was a very good starting point. As you would say, today there is an app for everything. The same question arose in the minds of the service provisioning teams. Is there a service model that can do? Managed services was a very good start. Frequentis is already providing managed services for the application software and the platform software for many customers. While doing so, we observed the many benefits of the managed service model, but we also sensed that there is room for more. And this room for more would mean a transition to the as-a-service provisioning. Speaking of benefits, I can mention here, in a world in which do more with less is a business must, providing scalability, providing scalability is imperative. The scalability has to be flexible enough, though, to accommodate small companies as well as large companies. Companies are now able to trade their fixed infrastructure spending for on-demand subscription costs. As you may know, one of the major lifecycle topics for each project is the commercial off-the-shelf hardware refresh, which with this model would become more or less obsolete. The as-a-service model also allows a reduced time to benefit for our customers, as a cloud can today easily be deployed in a matter of minutes, and if you have already the application in a containerized environment, you just deploy it and you can benefit from its value in a very shortest time. What does this mean for the end users? Well, by shifting the burden of the technical operations to the as-a-service provider, you let your teams actually focus on what they do best, namely your business. Namely, this would also mean that you no longer have to provide extensive trainings or prolonged learning curves for custom hardware, as the knowledge shifts to a commodity IT solutions. One of our first customers who recognized all these benefits was Avinor in the currently ongoing UTM project. Just to mention a few words on why Avinor decided to go this path with us. As the number of drones in the airspace managed by Avinor increased exponentially in the past years, there was a clear pressure which was put on the tower operators to manage also these additional players. As you may know, these additional players play, however, by different rules in terms of speed, in terms of weight, in terms of flight trajectories. Therefore, it was pretty much clear that the tower operators have to focus on what they do best in order to ensure safety and security for the already traditional another advantage on why Frequentis decided to go with us is the scalability. Yeah, the as-a-service model allows an easy from one airport to 17 airports, what we have currently in this Avinor project. Also, Avinor and Frequentis are already involved in many projects throughout the years. We provide service contracts for many projects with Avinor. Therefore, Avinor relies on our experience in the ATM world, and we can make the bridge into this new UTM world. To mention a few of project highlights, we are going to integrate 3 different cloud solutions, including cloud security and cloud orchestration, in a 24/7 operational model. All this integration happens on one platform, on our Mosaic Swim platform with SmartSys as a front end. And we have 4 different applications, front user-facing applications, whether this is controllers or private drone operators. In the background, I can tell there are more than 50 services that we orchestrate in this solution. To go a little bit more in detail, this is actually on a high level the view of the as-a-service provisioning, which is perceived by the customer. You would say this is very simple, and this is actually here. Yeah? We take the data from the tower controllers, we take the inputs from the private drone pilots, we aggregate them also by connecting the ANSP cloud which have maybe sensitive data, and aggregate to all stakeholders. In this privacy-oriented world, I think it is safe to mention, it is important that the data, the actual data sensitive data, anything that might be subject to GDPR rules, stays with the air navigation service provider, in this case Avinor. We just aggregate data at the minimum necessary of data in order to provide the value. Let's go a little bit in more detail. How do we do this integration? Well, we have different cloud solutions. For example, we have our Frequentis tenant, which in this case runs in a Azure tenant, on which lies our platform, our SmartSys front end, also the integration services in the background. We also integrate to this the data from our mobile application provider, and together, in this particular case, we form the use-based service provider. In addition, we have also our forum provider, which is a first in this project, and a first generally in Frequentis, as we make with this, we build with this the first level channel towards the end users. Now, just to have a picture of what lies behind this, this is a very high level of the services and applications which run in the background. You don't have to count the boxes, there are more than 50 of them, which we take care of, and thus take away this technical burden from our customer. What is the future? Where we could go from here? Whether this is Avinor or maybe another customer of ours. You want to integrate additional regional services which are already built on an existing infrastructure. Or you want to extend this as a service model to further partners. Yeah? Maybe these partners handle daily with tens, hundreds of flights. While I think our controllers are very resilient and highly capable people, I think this amount of drones would be still a bit too much. So maybe you would have dedicated fleet operator teams. And I'm speaking about supplemental services. You might also want to add future services like drone detection, like public safety, search and rescue services. Maybe you want to operate mobile network operators in your solution. All these stakeholders may come with their own cloud solution, whether this is Microsoft Azure, Amazon Web Services, and so on. Needs it also add commercial services with commercial. Okay, I hope you can hear. Is it better? Continue? Yeah. Okay. So yeah, I was speaking about private users. So maybe you want to add services to your private user with a commercial payload. Or in this era of information, you might want to stream 4K video without quality loss. All this is possible. You have to consider this platform, this integration platform, as a Lego platform, for example. You can pick your services, your components, based on your current business needs. And the aggregation happens in the background. So, why use Frequentis in this journey? Well, in the past slides, I put a very big emphasis on the service integration and management. We provide solutions and managed services independent of a cloud provider. What this means for you is that we are taking care of the service delivery, end-to-end monitoring, and you no longer have to deal with different SLAs from different providers. You will face from us one set of SLAs. Why Frequentis again? Well, we are a company with cross-domain know-how. I can literally walk across the aisle to one of my colleagues and ask them for their expertise in whether it is ATM, public safety, AIM, and so on. We are big enough in order to provide state-of-the-art services across multiple domains, yet small enough in order to be able to provide this in an agile way. We are unifying these new commodity cloud solutions with our managed services experience and version 3 aligned processes, and we also maintain several other ISO standards, safety and security and development standards. These are the most relevant for our case here, but this is by far not all of them. No? With all these benefits, Frequentis is the enabler for your future business, because we can provide you future-proof solutions and platforms on which you can deploy your business in a pay-as-you-grow principle. Yeah? As soon as your business, this is valid also for smaller companies which are allowed to grow, but also applies to bigger companies which in more difficult times, see 2020, can scale back and just pay for the services they are needing at that moment in time. Yeah? And in the end, it's a question of maturity from my perspective. Yeah, Frequentis is committed to the ATM industry for many years, which is why I can say that safety is in our DNA for more than 75 years. We have a common understanding for safety and security and how they converge. Today, the systems are fairly complex, and this complexity will only increase in the coming years. The same is valid for the safety and security principle. As I mentioned, anyone or almost anyone can deploy today a cloud in a matter of minutes, but doing this in a safe, secure, reliable, and sustainable way, for that you need a strong partner on your side, and that is Frequentis. We are living this new normal, and I hope that you can join us in this journey as well. Thank you very much for your time.
Thank you, Janos, and thanks to Thomas and Marian for this exciting presentations. Now we have the chat going on. There is time for questions. I hope sorry about that, we had some audio issues in between, and you see this is live. And as a speaker, actually moderator, I can take off my mask at the moment. We are of course taking special precautions that everything is running according to the health and safety of our employees and also the production team here. So there are some questions there were some questions. And the first one I would like to address to Thomas Haschberger. Thomas, how can we ensure the ED 153 compliance for open source components like Docker, Prometheus, and so forth?
I cannot hear Markus.
Yeah, I think the question was, unfortunately I was not able to hear you completely, Markus, but I think the question was about safety compliance for open source components. What we provide here and what makes it much easier than for you with your regulator is for open source in most cases a COTS assurance, which is a typical process for commercial off-the-shelf software, but also for open source components. So and that's where our safety department is providing, together with Mosaics, a lot of these documents, and it's a lot of paperwork mainly to provide that COTS assurance, and that's coming with the Mosaics framework.
Okay, thanks. There's another one that is actually for you. Do you allow to integrate third-party services on the same platform as Frequentis products? And if there are more questions, please put them into the chat.
Mm-hmm. Yeah, thanks for this question as well, a very good one. And yes, we want to provide this opportunity. That's one of the goals with this platform. of course, this has currently to be aligned with the customer, and finally also with acceptance criteria then for the overall solution. So not that straightforward process currently available, but definitely something which can be together with then the customer and the one who operates the system, and together with the alignment on acceptance criteria, something which is supported.
All right, thank you. Yeah, Florian, here there are many clouds in the pictures, that is right. But we ensure that everything is working fine. Yeah, are there any more questions? Please put them into the chat. And thanks for those who posted from where you're joining. This is exciting to see people from all around the world, from Indonesia, from, whoa, Mexico. It's night for them already. Tunisia, Romania. Well, Singapore, Iceland, Indonesia have already. I see one question which is relating to AI and automation. We would like to address that in getting into contact with you directly. Are there any more questions that you want to answer? Because we are reaching actually the end of the session, so there's the last chance for any last minute questions now. If somebody wants to put that into the chat. Let's see if there's something else coming. Okay, there's one question about cybersecurity. Could you give more details on cybersecurity? Are you using a public or private cloud? How do you deal with the issue cloud activation and GDPR? I think that is. Thomas, can we have a very short answer on cyber? I think the topic is too extensive to discuss that in 2 minutes, I would say.
All right, but whoever asked the question is invited to get in direct contact with us, of course, to get into more details here. Yes, security is, I think, probably one of the advantages with making use of cloud technologies, and not a disadvantage. And now we have all the processes in place to have, together with a patch management for our components, and of course all the measures which need to be applied by the operator of such a cloud. And I'm here, we have to see the differences then between the private and the hybrid and the public cloud, of course, but security is definitely an item which becomes more and more important, and is, my opinion at least, by using these state-of-the-art technologies, much better covered than by anything else. So make use of all the security processes which are applied to the cloud infrastructure, and then we are on a good way here. But if we want to go into more detail now, how we apply our security processes and patch management, then I would welcome here a contact then to go into the Frequentis processes.
Thomas, so that brings us to the end. We're reaching the end of the first session today. I hope you liked what you heard here so far. Make sure to click the button, subscribe to our YouTube channel. If you want to have some personal follow-up, either contact the address provided or contact your local Frequentis representative. The next session will start in an hour from now. It's 10 o'clock CET, so it's an hour from now, and it's about rethinking ATC towers. And for that, I would like to wish you a nice day. Have a nice day, and enjoy the rest of the day. Bye-bye from the first session. See you. Hello viewers and welcome back to the 2021 edition of Frequentis Connect, the place to be, the place to meet for ATM professionals. Welcome here from the Frequentis headquarters in Vienna in Austria for this unique and exclusive live broadcast. Today marks a special day and I'm really excited that we're doing this actually today, that we have this ongoing at the same time as we would normally be at World ATM Congress in Madrid. We are not there, but we're there in October, and I'm really much looking forward to it. Now we are in 2021, and it's certainly different. We are entering an absolutely new normal, and the new normal looks different for aviation. The traffic is, for instance, nowhere near where we want it to be globally. But there are regions where we see positive signs. For instance, in the US, just recently the CDC declared that people can meet privately without masks and social distancing. And I've seen pictures from France, from Australia, where they actually are together without masks and have something like an almost normal life. So that's really exciting. So how does the new normal going to be for aviation? There's two things that I would like to highlight. One thing is digitalization. And I'm not just talking about the digitalization of products and technology, but also about processes and the way we're working. And the other thing is certainly green aviation. I don't want to spoil it too much here. My experts in the next session will talk about this in detail. In total, we have ourselves got 5 sessions today. This is now the second one. We have close to 400 subscribers for this session, and I would like to welcome you all from wherever you're joining. Hopefully the chat is exciting, so please get yourself involved in the chat. There is the YouTube chat where you can post comments, post questions, and to get it going, just post there from where you're joining. The country, the city where you are. We are really interested to see from where you're joining us. Questions also, please put them there. We try to address them at the end of this session. And if it's not possible, we'll get back to you to follow the things up. There is also the possibility to send us questions by email. If you prefer that, we're going to run it through there as well. So hopefully, how is the chat going? Let me see some excitement there. That is great. Just a reminder, if you see what you like, if you like what you see, hit the like button on YouTube, subscribe to our YouTube channel, so that you're not missing any updates. Next session, let's get into it. Rethinking ATC towers, empowering ANSPs for the new normal. I have 2 great speakers with me, 2 great experts. I've been working with them for a very long time now. The first is Thomas Singer, Domain Sales Manager Tower, and Eric Wernsberger, the Strategic Product Manager for the tower solution. Thomas, over to you. What can you say about the digitalization of towers?
Yes, thank you. Thank you, Marcus. My name is Thomas, and I want to tell you about the new normal and tower solutions we have at Frequentis. First of all, what is the new normal? What are the challenges we had to face in the past? After the deep impact 1 year ago, we had a low-level recovery of air traffic in the world in the summer season, and a lot of fluctuations. Sorry.
Noch nicht.
A lot of fluctuations at the end of the year and also at the moment. For the air traffic, this means traffic is less controllable, less predictable. It's fluctuating, and based on the statement of Lufthansa, touristic flights will recover faster than business flights. And we as a Frequentis want to give you an overview how we can face these challenges, how we can help you in getting in a good manner through this next near future. And we'll hand over to Eric, who will go in more detail about our solutions during traffic recovery and the challenges we faced.
Thank you very much for the great introduction. You've all seen a graph on the previous slide which looks scary. We're all used to graphs where you can see either a a steady growth or an exponential growth, ideally, or in negative cases you can see a decline. What we saw is we saw a lot of very short waves. So basically, what that graph shows us is that we're in a present situation.
We did take, and that we're pretty safe to share with you today. So what will a normal look like in, I would say, a certain time from now on? Talking about this conference here, it's wonderful to have you at your monitors at home. There are a lot of people attending this session today. Unfortunately for me, I can say I just see a lens here, and I think we can all agree on the assumption that it will be great when we can see each other face to face again. We're talking about a basic human need here. So people will travel. As soon as it's safe again, then people will travel. And it's something we've seen in the past. There have been crises in the past. There have been 2 oil crises. There's been 9/11, which we don't need to elaborate on any further here. But after all these crises, the traffic figures did first recover, so they got back to their previous levels, and then they even continued to grow to the level where we had in 2019. So that's one safe assumption. Then the next thing is peak hours at airports. The hub and spoke system is still available. So the network airlines, they still have their arrival waves, they still have their departure waves. In between, depending on the airport, it could be rather quiet. So I hope you can see that even with the situation that we have today, where the figures are lower than they usually are, but the basic traffic patterns are very similar. So in certain times of operations with a reduced workforce at the towers, efficiency will still be key. There's one new challenge that we did not see in the crisis previously, and that is that sustainability and that environmental friendliness is such a high objective. So there are incentives for airlines to reduce their CO2 footprint. There are incentives for ANSPs to reduce noise levels over residential areas. And these all flow into the entire case of air traffic control at towers, because in some cases even airlines receive new slots for taking new destinations if they can prove that the CO2 levels for their regular traffic or the traffic they had before requesting the slot have actually gone down. So as you can see, a lot of challenges, some would say problems, but we do not talk about a problem without a solution. And for this purpose, I would like to hand over back to Thomas, who will start talking about which solutions we have for this.
Yes, as you know, Frequentis has a very broad portfolio to support you in air traffic control and in tower control. First of all, it's the communication part. So we have an IT-based VCS. It's a new VCS we can offer. Frequentis is famous for the VCS, but it's by far not the only part what we can offer. We have products in the information and control segment. We have electronic flight strips, which is one of the best on the market. The latest success or a good ongoing project is LWNL in the Netherlands. We have recently included in our portfolio a departure manager, pre-departure sequencer. We have tower support systems for ATIS, for DATIS, for meteorological information, for tower environmental control, and navigational aid status. So all these things, all these integrated tower solutions, which we did already in the past and which we follow also in the future, we offered already since years or nearly decades actually. Surveillance. Surveillance, as you know, ASIM GCS, so it's also new in our family. We have a very advanced ASIM GCS display with the acquisition of integration of Atrix in our family last year.
We have tracking competences for the air traffic, on route traffic like ARTAS, but also on the ground. And we offer also multi-data sensor fusion for advanced ASIM GCS systems of all levels. In addition, on the surveillance part, we offer the camera surveillance. So one technology or one use case is a remote tower, but also visual and video surveillance can be used also on large towers, on large airports for local blind area coverage, for local gate surveillance. So all these products will support you in the air traffic control and in the ground control. For the visualization, as I said, is also the camera solutions for remote tower. Remote tower is not only a camera solution, it's more, it's the complete environment which can offer for normal and remote towers. And all these solutions we have, they know each other. They are integrated each other. They can exchange messages to each other. And the platform, what we need for that is an integration platform. We call it Mosaics, which are data bus beneath, and all these, so that the integration is very tight, it's very comprehensive, and we will see later in this presentation what are a use case of these integrated tower solutions. And now I hand over again to Eric, and he will also give you another use cases and advantages of our solutions.
Thank you very much, Thomas. Next, I would like to take you on a journey of rethinking ATC towers. And on this journey, we're gonna compile some thoughts which lead us to the final solution. The first thought is save fuel and reduce noise. How can that be done? So if you have less times for taxiing on the ground, and if you have more efficient departure procedures, and if the system knows exactly when to apply which taxi routes, which departure procedures, then you can save a tremendous amount of fuel and taxiing on the ground, and you can have departure procedures which are less of a hassle for the locals which live around the airport. Then integrate your tower applications. The tower applications that we promote here, they're well known to you. They've been in operation for many years, in some cases even decades. But the power that they have when they're integrated is something that we're just beginning to explore now together. Automate your processes. It's easy that if the system knows things from different systems, from different subsystems, it can count one and one together and can provide a knowledge base which can either semi-automate your decisions or in some cases even automate them if they're completely straightforward. Then another thought is the business cases for regional airports may be challenging nowadays. So with the traffic numbers that we're seeing and with certain airline customers reducing their scope of service at these regional airports, it may be difficult to keep them. Why not keep these airports alive with a remote tower solution? And last but not least, contingency operations are also a way of, I don't even want to use the word, but it's most suitable here, social distancing. So if you keep, if you want to keep teams separated for the sake of safety and healthiness, then you can also consider using a contingency solution where you would have pretty much exactly the same solution that you have in the tower, certain miles away from the ATC tower. Now, I would like to go a little bit away from the use cases, more towards the technical solution that enables us to do this. So on the left-hand side of this slide, you can see the products that you're used to from Frequentis. So we have the voice comms, we have electronic flight strips, we have our MET display, we have surveillance, we have video, and all of that is combined also on the engineering level with a system management platform. And all of these applications, they communicate via our Mosaics framework with each other. So we have an unlimited means of data exchange between these applications. That's one thing. Then they're also on a common platform for monitoring, deployment, configuration, and so on and so forth. And then in addition to that, we invite third parties to come into this framework as well. These third parties could be systems from airports, for example, and they provide a very valuable basis of data to the Frequentis applications so that these objectives that we discussed on the slide before could be fulfilled. Thomas, you've prepared a couple of additional use cases that you can share with us right now?
Yeah. So what does this mean? So we have, with this platform, we can provide a back-end integration and a front-end integration. A pure front-end integration is just putting different applications on a monitor, and the applications don't know each other. This is not the challenge, and this is not the way we want to go. We want to go to a deep back-end integration. That means that the applications can exchange messages beneath each other. For instance, I have an electronic flight strip system integrated with the ASIM GCS system. Clicking on the flight strip will highlight a label on the ASIM GCS and vice versa. Clicking on the ASIM GCS, the controller can immediately see the highlighted electronic flight strip. The controller can input commands into the electronic flight strips like taxi out or go for land. He can do it on the EFS, he can do it on the ASIM GCS. Alarming can be shared on the applications which are in front of the controller. If the ground surveillance is detecting an alarm, conformance monitoring, for instance, so the wrong path, wrong taxi path of an airplane, or runway incursions, this can be shown on the ASIM GCS, but it can also shown on different applications. It can be shown on the electronic flight strips, it can be shown anywhere. Other integration features are weather information. Weather information can be shown on a screen, on an extra screen, or it can be integrated on the visual enhancement screen, on the video screen, or on the ASIM GCS screen. There are a lot of features which are not rolled out today, but can be, in addition, be integrated also. We can also integrate third-party integration, integrate third-party products, third-party solutions from different stakeholders here. So there is a lot of possibilities to shape, to create a controller working position, to enhance the situational awareness, to make a concentration of information, so that the controller does not have to look on different screens, typically 5 or 6 screens. My personal record in a site survey was 11 screens at a tower position. Imagine 11 screens, so the tower position was 2.5 meters wide. In the middle was a chair, and he had 5 mice and keyboards in front of it, in front of him. So all these things have to be merged together and have to be put into a simple way, in an HMI designed way, and back-end integrated. And that's the reason for Mosaics and our solutions. What we did, and one additional integration example, I hand over again to Eric. This was Atrix.
Yeah. Thank you. We've discussed use cases that integration could benefit from. We've discussed how technical integration can look like. So we've explained more or less in detail how our Mosaics platform works. But we don't only do these measures, we also are constantly on the lookout to extend our portfolio and to make the tower portfolio as complete as it can be. And now I would like to welcome the latest member of the family, Atrix, officially in this podcast. And I would like to show you how TowerPad is their flagship product, will enrich the tower solutions that we can provide to you, dear customers, in the future.
The video, please.
Dear audience.
Welcome back. I hope you enjoyed the video. I think it's a very cool video. Also the music, I like this music. Even the beat of the music was synchronized with the movement of the aeroplanes. But you saw a lot of features of this tower pad based on routing and planning. You saw a case of conformance monitoring. You saw a case of a handover with a handover button in the tower pad. So hand over the the responsibility of an airplane from one controller of the other one. So this solution is especially designed for level 3 and level 4 control, and also capable for level 1 and 2. But we can integrate this into our family. So here are design concepts which show potential tower controller. Could be a ground controller in this case. You see the ASMGCS display on the top. You see our smart strips, the electronic flight split system. On the left-hand side, you see the IT-based voice communication system. On the right-hand side, you see the tower support information system. This is our smart tools, which are handling the weather situation, the runway, the active runway, ILS switchover, runway change, ATIS, QNH, and all these things a controller has to know. On the right-hand side, you see a video screen. This is not just CCTV. It's part of our Smart Vision product family, which is, in this case, a PTZ cam. It could be also a mini panorama or a larger panorama. But for this visualization here, for this concept, it's a PTZ cam. But now I show you, as I mentioned before, some integration examples. Before, you see that the labeling can be displayed on the video screen. Yes, I'll show it again. Yeah. So the controller sees when he clicks on an electronic flight strip. This is another integration example. If he clicks on the electronic flight strips, he can immediately see where is the aeroplane on the ASIM-GCS display, but where is the aeroplane also on the video screen. And the PTZ camera is automatically directing the view to this aeroplane on the runway, on the taxiway, on the stand position, on the gate position. And it's also showing immediately the highlighted label. He sees the status of the plane on the video screen. Yeah. He sees also the status on the plane on the passenger bridge. He sees what is the status on tank turnaround status of the aeroplane. Also, we can shift the weather information. We can move the weather information to that display, but we can also move the weather information to the ASIM-GCS display. So the controller has the full visualization on where the wind is, the wind sensor, the wind direction, and is situated exactly at the position where the real Met Garden is in the real life. So he can has an immediate feeling which runway is open and what is the wind situation there. What he can also do is move additional weather information to the main screen, like ATIS letter, like QNH, like dew point and temperature. So that means that he can avoid, if you like, he can avoid one screen. But the integration is not over here. So just to say, we can deliver all integrated solutions in different setups, in different screens. We can use also smaller screens. Here in this example, we can also move the video screen on the main screen. This is flexible enough here. And it's so flexible that we can do it by configuration, also by role. So there can be a role which is called integrated working position, where a lot of things are integrated in one screen. But there could be roles where all the information is shown on separate screens. But this is not all. We are also in the position, if there is, for instance, a tower controller, if a tower controller is using more the ground surveillance system, and as an additional tool, he is using the electronic flight strips. So we can integrate the electronic flight strips also to the ground surveillance system. The strips can be integrated to the surveillance systems, so they can automatically move their base based on the real location of the aeroplane, if this is wanted, if you like this. If not, the controller can also manually move the strips in this small strip bay if he is more concentrating on the surveillance-based control. Another possibility, and this is for Frequentis, we have a USB on that. Due to the fact that we have an IT-based voice communication system, we also can move special components of the voice communication system to an integrated working position. So we are completely flexible what and which components we want to move there. it might be necessary to move some radio buttons, frequency buttons to the integrated working position. But also very important could be to move some call buttons to the working position. Why? Exactly on that location, I show it back. Exactly at that location on the ISMGCS, there are buttons, handover buttons, where the controller can, without voice, can hand over the responsibility of an aeroplane to another sector. In this case, for the tower controller, another sector is the ground controller, or it is the apron controller, or the approach. And next to these handover buttons, we can move also some direct call buttons to call exactly that controller to which the responsible person is handing over the responsibility. Normally, he need not to call this guy, yeah? But there could be possibilities, there could be reasons to call this person, and he has all these most important functions on his main control screen. At the end, there are then a so-called single screen integrated working position with all the functions back-end and front-end integrated. In the past, I had a lot of talks with, especially at exhibitions, with controllers and so on, and they say, okay, but what happens if the mainstream fails? My voice communication is maybe also lost, and it's the most important thing. No, the voice communication panel on the left-hand side, it's not in the same scale, of course. The voice communication on the left-hand side will stay. This is clear. So the controller has all time, anytime, full control of the voice. And if there's anything on the main screen, the voice screen is separated, and he can continue everything there. And now I would like to sum up our presentation. And I would like to tell you what you should remember if you go home, if you leave this presentation. Frequentis has the largest tower portfolio on the market, starting with the voice communication, to the automation systems, to the ASMGCS, to the integrated control information, to the ground surveillance, air surveillance, visualization, remote tower technology. So we cover the entire tower. You can equip your entire tower with Frequentis solutions. And we can integrate them all in a common integration platform for all components. Eric can tell you an example of our solutions, which are special highlighting, and I will give you the word for that.
Thank you very much, Thomas. Also, thank you very much for taking us on the fast track of this journey from going from an 11-screen environment to, or actually there were just 5 in this case, but 11 was your
this
was
was my personal record in a
yes.
site survey, yes, yeah.
But we ended up at a more or less single screen position. So of course we know that this was a very fast move that you've seen in less than 10 minutes. And we also understand very well that sometimes incremental approaches are the ones that are more sustainable. So every single step that you saw on that journey is a step that is a possible deployment scenario. And not only that, it's a tower position can have a different setup than the ground position, and they can have, again, a different setup in the clearance delivery position, because on a clearance delivery position, you'll obviously would like to see more flight strips and departure management, HMI, and on the tower position, The surveillance display is more important, and along these tracks you can have all kinds of variations of which portions of the entire system or entire solution you would like to see. So one word to that. Just some final words from my side on the tower solutions. So in the next video we will show you, we've started with a DFS solution, and meanwhile it's become very powerful. Since our portfolio is so big and everything is integrated with each other, the electronic flight strips are meanwhile the central data repository. You collect all the data, process all the data, and can also redistribute them, and the other applications can benefit from this very powerful base. And since all of these products and components are now in our portfolio, if you procure a tower solution from Frequentis, then you can be sure that the project management comes out of one hand, the delivery comes out of one hand, and that all of this is done with a very agile and user-centric approach, and with a delivery model which makes sure that the system is always kept up to date, and yeah, the standard updates are a more or less straightforward task. Thomas, I think we've been talking enough for now.
I think yes, yeah.
Our customers also have something to say about our solutions, and now we would like to hand over to a very dear customer of ours.
So we will see a video.
We were looking for a partner which could support us in our process to digitize the entire tower processes, replacement of the total tower system, and improve safety and efficiency in the next 10 to 20 years here at Schiphol Airport.
We want to modernize the systems that they are using in the tower.
The ultimate choice being Frequentis as the supplier for the entire tower system, and as a first step, introduction of the electronic flight strips.
Electronic flight strips enables the air traffic controller to do his work more efficiently.
The panel behind me is my main working position to keep track on the aircraft data and the electronic flight strips.
With the new electronic flight strip system from Frequentis, we have access to a lot of more information, and the system can do a lot of smart things with that information.
We can put so much more info on our data strips when we pass it on than in the old days where you had to write down everything.
One of the benefits for the controllers is that they can just use the system digitally.
Improving safety, improving efficiency.
And transfer strips very easily to their colleagues.
We can pass on data from one station to another much better without loss of information.
They can just swipe it on their tablet and it's going to the next controller, even if that controller is in another tower.
So you can stay longer focused on your own working position.
At Schiphol we have two control towers, so that interaction is much easier with electronic strips.
Well, the first thing you notice when you come up to the tower now is you miss the sound of the strip printer and the clanking noise of the metal strip cases clutching together.
That means it's less noisy in the tower.
Systems like the electronic flight strip system, or actually the entire tower system, are systems which ANSPs like LVNL will use for 10, maybe 20 years.
So it's really the first step for us.
So a choice for a system means a choice for a long-term relationship.
The cooperation with Frequentis was great. They had a very capable project team on their side, making the system to the wishes of the air traffic controllers. I can just give them a call with questions and they will respond immediately.
Digitization of the operational process is a key factor to improve those operational processes and to ultimately create value in terms of growth for our stakeholders, for the airlines.
Together with LVNL, we are committed to develop the digital tower of the future.
In the future we will also extend EFS to be used at the other airports in the Netherlands. So it's a growing process.
It's a start of a new beginning with the fully digitization of the control tower processes.
welcome back, everyone. I hope you liked the video. And now it was time for the question and answer session. And I look forward to the first question.
Yeah, thanks. Thanks, Eric. There are some questions actually in the chat. I hope you can hear that already. There was one question from Alain about tower and terminal operation in many airports. They have demarcation lines. Does Mosaics have the possibility to integrate with the AODB, and what algorithm it has to make data check and accuracy?
Well, data check and accuracy, I will start with that part. That is something which is implemented in that case. So when you're talking about AODB, then we would do an integration with Smart Strips, our electronic flight strip solution. And there are mechanisms within this product to check not only the accuracy, but also the correct formatting of the data. So it would have a check in the background with just some certain algorithms which would just make sure that the format is followed, or for example that the data that is entered is part of a pre-populated list and not something which is just made up. And only then it would be sent out over the interface. So that's part two of the question. Part one of the question is, so the demarcation line is somewhat fuzzy. AODB is a third-party application as we consider, and if it integrates with our Mosaics framework via the open standard that we provide, then it can fully benefit from the data and services that Mosaics provides.
Okay, thank you, Eric. Any more questions? Please use the chat. I'm happy to answer them from the chat here. So if you have questions, put them into the chat, or there is also the possibility that you put them into into an email. I'll wait a while because I know that the live stream is about 20 seconds or so delayed. So let's see what is coming on the chat, if there are more questions coming. Okay, I got one question actually, and that refers back to LVNL, so I think it's about Eric to answer that one. In the video you showed us, LVNL talks about the electronic flight strips were just the first step. What is the next steps for LVNL?
Well, the next project, which came after the EFS project, so the EFS project is the project we started with back in 2017. So meanwhile, we've been live for nearly 2 years with the EFS system. Then the next project was introduction of additional services. So we have a SID allocation service now currently in development, which provides an SID to the connected systems based on certain input parameters such as departure runway and takeoff route. So also the departure manager project is currently underway. So we are integrating the Atrix departure manager into the entire system, and then afterwards the tower pad will be brought into the game, into the whole Tower 2020 program with the surveillance display, and also safety nets will be a part of it.
Okay, Eric, thank you. Thank you.
You're welcome.
That was interesting. There is one more question coming, and I see that from the YouTube chat, and that's more a technology question, and it has already raised interest in the previous session. So the question is about cybersecurity, and let's see if Thomas wants to answer that, or Eric. So how do you deal with cybersecurity in the integrated tower solutions? And I think the answer will relate a little bit to Mosaics. We heard it before in the previous session. We had our head of technology there who answered already that question, but I would like also to get either Eric or Thomas the chance for this question.
Yes, cybersecurity is a topic that we have a dedicated team working on. Yes, Mosaics Mosaics is also the framework which relays this topic and brings this topic to a very important level. In general, we have plans which foresee usage of always the latest components. So for each, I would say for each patch that is available, for each operating system upgrade that is available, we go through a whole chain of processes in approving it for the operational use. And also with our release model, we ensure that always the latest components are used, and also there are checks which are done constantly on verifying the vulnerability of the system, and we also have a dedicated department which looks only into this aspect.
Okay, thanks Eric. Yeah, pretty much this release model is really intriguing, and I know that there is what's called an evergreen release model to that. I don't want to spoil anything here. That's going to be part of our session about VCS IT as well. But as it's software, we take care of this by constantly updating it. So one more question which I received through email, and that relates to our new normal with the low traffic. So the question is, traffic figures are down by 80%. Why do you think efficiency is something we need to take care about these days? Eric, Thomas, who wants to answer that?
Efficiency. So that means efficiency is always important. It is clear that the airports at the moment, on the land side, on the air side, are not on their full capacity. There is, of course, room above that. But the controllers on duty, who are on the tower, they have to face also in these times and also in the near future challenging situations. So they are not bored. Yeah? They have their work to do. They are on normal load. They are sometimes on 100% load, and there are also peak hours there, and there are peak situations and critical situations also in these times, also in the level of 60%, 70% of pro-COVID traffic. And it is also, especially also in these times, very important to be efficient, to have a good overview, a good control, a good situational awareness about the traffic, and especially prepare now for the upcoming near future, upcoming month, upcoming year. So where the traffic is seasonal, it's fluctuating, it's less predictable. And so if the ANSP has a technology in place where he can cover high load, but also can easily downgrade or reduce the load, and the duty, the persons on duty on it and the tower is especially also in these times crucial.
Okay, yeah, there is questions coming in more by email on the chat, so I'm sure there's a lot of people still on the chat as well, because I've seen so many different places again, and thanks for joining that. This is awesome to see from where the people are, from Albania, from Albania, Oman, UAE, 17 degrees Celsius in Australia. Yeah, makes me jealous really. We had snow here on my way here to work. So yeah, one more question I get here, and that relates to what I had on the beginning about the greening of aviation and green ATM. How do your solutions help to achieve my environmental objectives?
Of course, we are on the tower, so we are mostly focusing on what is happening on the ground. There are features on the ground who can help to reduce taxi times. As I remember from some reports, and not old, too new aeroplane, it was an A340 with 4 engine, burns about 600 to 700 kilograms of fuel only for taxiing. And So we have features in place. So this is first electronic flight strips, who have a more organized, a more efficient way of operation, as you saw in the video from LVNL, and reduce taxi times and reduce the engines running on the ground. Another very important feature is the pre-departure sequencer, so it's the DEMA, Departure Manager, to predict the takeoff time in a more accurate manner, to predict the off-block time, the startup time, the target startup time in a more accurate manner, so that you reduce the fuel burning, so the time where the engines are on the ground, by up to 40%, what studies give. And so this is the contribution what we have here in the tower environment for air traffic control, for CO2 reduction. Of course, the other features will help you, but these are the most important features for these reductions.
Okay, thank you, Thomas. So that brings me to an end of the session, actually, and I have to really thank everybody for joining. I hope you liked what you saw, what you heard. Make sure to hit the like button on YouTube, subscribe to our YouTube channel. For follow-ups, we would like, and if you would like to have a follow-up, send us an email or get in contact with your local sales representative, with your local person, point of contact. I'm sure there's things that you want to talk about, that we want to talk about and get closer. The next session will start in 30 minutes from now, 40 minutes from now at 11:30 CET, and it's going to be about UTM, SWIM, and ERM. Make sure to join. If you want to join, you can stay on this link here. It's going to be on the same link as before. Yeah, and that's it for today. I was happy to be your host today. Have a great day. Enjoy the rest of your day.
contact Eagle 102.
Eagle 102, confirm established.
Affirmative.
Thank you, contact tower 119 at decimal 4, good night.
1184, 102, good night.
Iberia 3575, proceed after solenoid direct Delta.
After solenoid Delta, Iberia 3575.
France 2039, direct Sydney.
Direct Sydney, France 2039.
Tirol 78 Victor, contact Wiesbaden 3435, servus.
13435, 78 Victor, servus.
Tirol 258 Kilo, contact Wien Reda Monterey 3 decimal 8, servus.
In radar, good evening, CSA 607, heading 030.
Frequentis 607, good evening, identified camp flight level 160.
Frequentis level 160, CSA 607.
Austin 459, 2700, climbing 5000.
Austin 459, guten Abend, identified camp flight level 240. 78 Victor, direkt Rattenberg.
Direct Rattenberg, Tirol 78 Victor, Dankeschön.
Guten Abend, Austin 180, out of 220, descending 150.
Austin 180, guten Abend, information Whiskey, expect a less 16, no speed restrictions, direct Wagram.
Danke, direct Wagram, Whiskey on board, B180.
Seagull 102, descend 2500 feet.
2500, Eagle 102.
Seagull 102 to make a short get 2500 feet.
Affirmative, that's 2500 feet, 102.
Seagull 102 turn left heading 230.
Left 20, Eagle 102.
Bill radar, Iberia 3575, good evening, leaving 4000.
Iberia 3575, good evening, identified camp flight level 170.
Landing 170, Iberia 3575. Good afternoon, from 2039, airborne.
Good evening, stand by. Seagull 102, left 180, clear direct 16, but established.
180, I will take reestablish 102.
Advance 2039, good evening, identified camp flight level 240.
Landing 240, Alphonse 030.
Austin 477 Echo, contact Wiesbaden 3435, goodbye.
Run 3435, goodbye, 7477 Echo.
Turn 508 Kilo, stop camp flight level 150. Austin 180, descend 5000 feet, change from 010.
Established 1.
Hello viewers, and welcome back to the 2021 edition of Frequentis Connect, the place to be for ATM professionals. I'm really excited to have you all here joining us for this interesting session. We have ourselves, in addition, now 3 more sessions. We had already 2 sessions, and it's great to be here. Today really marks a special day because most of us would normally be at World ATM Congress in Madrid. Now this is different. This is going to happen in October this year, and I'm looking really forward to meeting you all there. So we are in a new normal. We are heading towards a new normal. But how does it look like? I mean, traffic is definitely nowhere near where we want it all to be. But there are positive signs ahead of us as well. For instance, in the US, the CDC declared that people can meet privately without masks if they are vaccinated. And also I have seen pictures from friends from Australia and New Zealand that they can meet and talk to each other and almost have a normal life. So there is positive news and positive things ahead. And that's why I'm really looking forward that aviation is going to recover soon, and I hope you do that as well. So when we go into this new normal, what is it all about? It's two things, and one thing is the focus and the theme of Frequentis Connect. It is digitalization, and we're going to hear very soon what that means. We have the whole wave of digitalization starting with these new things, the new things that are flying in the air, and the other aspect of the new normal is green aviation. Focus on climate change, focus on preventing and minimizing the environmental impact that aviation has. And this can be everything. This can be flight optimization. This can be not having to build unnecessary structures. So a lot of different aspects. So this is an interactive session today. I'm looking here on my chat. This is the YouTube chat. So if you want to get involved, and I really invite you to get involved into this. I mean, I have the microphone, the speakers have it, you have the chat, and we would like to hear you. So if you want to interact, please let us know from where you are, post that into the chat, and let's get this going and let's get this excited. I'm really looking forward to this. Questions and comments, also use the chat. We're going to address them at the end of the session. And there is an alternative way. If you want to ask questions directly, you can send an email to invitation@frequentis.com. It's going to be posted as well in the chat, so we can also talk about these questions afterwards. So next ahead, and looking at the chat now, it's still quiet. So I hope we're going to have more and more people. I know there is more than 400 registrations for this session, and it is amazing. It's really great to have all that here, and we have almost 2,000 registrations for the whole day, and I'm really excited about that. While we get that going, let me introduce the next speakers. The next speakers is, first of all, Roman Stickler. He is the sales manager UTM and our expert on unmanned traffic management. Then I have Michael Kupsch, our ARM solution consultant. He is joining us, by the way, from our Frequentis Comsoft office in Karlsruhe. The same as Uli Kage joining us as well. Uli Kage is the SWIM solution consultant and a renowned expert on SWIM. And then it's my pleasure to also have Axel Knudsen from Avinor, Norway here. He's the head of UTM, and he also will join us in this session. And they are already in the call and waiting to speak. But now it's my time to hand over to Roman and ask him, okay, uniting the things that fly, UTM, ARM, and SWIM. What's it all about?
Thank you, Marcus. Ladies and gentlemen, very warm welcome from my side. I'm really keen to give you a latest insight on our UTM system. Let me start by following statement. Information management assures the provision of commonly understood quality information delivered to the right people at the right time. Most of you might remember this ICAO key principle. Furthermore, this statement is crucial when it comes to safety critical communication. Let me give you two examples. The pilot is the right person to receive the right information, like a NOTAM, at the right time before the flight. The policeman is the right person to provide the right information in order to close an airspace for drones during an operation. I will come to that point later on in our demonstration. This sounds easy, but get more complex with a rising number of new airspace entrants. There is a highly standardized ATM market on the left side. There is a steadily increasing number of new entrants with new needs and rising operation on the right side. The pace gets faster. The need for connectivity is evident. The need for advanced automation is evident since this new airspace entrance desires a bunch of new services. All these factors have been taken into account while designing the new UTM system. It enables seamless connectivity and the information exchange between all the stakeholders. Bearing in mind that we have to connect more and smaller systems than we did so far, procedures like data quality or review processes are getting more important in order to build the bridge between the manned and unmanned aviation. Let me give you an example. The UTM system handles AIM data, fully compliant according to SWIM principle. At the same time, it provides this information to new airspace entrants in an adequate format based on SWIM principle. Remember the first slide. ICAO set the rules. We realize them by connecting all the stakeholders. Aircrafts, ground services, and other new capabilities, like for example, counter-UAS sensors, are all considered in this new design. Information exchange services, together with common information services, facilitate the exchange of information between all the stakeholders. Realizing a single source of truth is enabled by a strong yet flexible architecture. Federating services where possible, ensuring consistency where needed. This allows for a resilient ecosystem. Interoperability, connectivity, and automation are the main factors in order to build such an ecosystem. Looking at this architecture, some of you might think, oh, this might be a lot of racks at our premises. Not necessarily. The Frequentis cloud-based approach allows for scalable, flexible, and dynamic business operations. Operators like ATM pilots and UTM operators are in the middle of this ecosystem. We enable them to execute safe and secure flights. When looking at this architecture, again, some might say, oh, looks quite complex, but please, let me show you that handling such a system is almost as easy as placing a purchase order in an online shop by following our intuitive approach. Efficiency is key. Now to the demonstration, please. Our UTM user interface runs in browser and can also be used on the mobile devices. It supports a clear and simple visualization, provides, for example, air traffic controllers with a common operational picture. There is also the possibility to authorize external and trained third parties to create restrictions for the airspace. Now let me show you how to create a flight plan. First, the operator creates a flight request for an inspection flight to check here a bridge portal. This would be a commercial use case. The operator has to insert different data like name, telephone number, email address, the max altitude, and also whether it's a commercial or uncommercial flight. In our demonstration here, it's an inspection flight, thus it's a commercial flight. So, and last but not least, the attitude. In the next step, the flight will be approved strategically and operationally by the air traffic controller. This happens very easy by a mouse click. In the next step, we simulate the drone flight. also here. Very easy to handle this operation. Now, let's assume meanwhile an accident at the crossroad within the flight area happens. Immediately, the policeman we heard before will create a temporary no-fly zone in order to avoid any interferences. The creation of a no-fly zone will automatically message any impacted operators with an appropriate message. Any flights planned will be cancelled. In the next step, you see this information that will be sent out to all the operators. Key takeaways here. What we saw here were basically two domains, each with highly complex processes brought together by a simple tool. This brings me to a real-life demo. This is our joint undertaking research program, GovUSpace, where the integration of unmanned traffic management and the air traffic management system has been tested completely successfully. USpace services in 7 advanced trials, like parcel delivery, border control, air taxis, with 11 unmanned and manned operation, have been tested successfully. 3 years ago, we designed this UTM system. Later on, it was validated by 2 ANSPs within the GovUSpace. Finally, this system has been successfully deployed at our first launching customer. Ladies and gentlemen, I'm happy to welcome Axel Knudsen, Vice President, Unmanned Traffic Management at Avinor Airspace Services, our first launching customer. He will tell us now about the system and his experience with this UTM system. Welcome, Axel.
Thank you, Roman. As Roman and Marcus mentioned, I work for Avinor ANS, Air Navigation Service Provider in Norway, where we have worked with UTM since 2018. Why we do UTM? In Norway, there is a very strong request from the drone community to be able to integrate into the airspace. We have several thousand members or entities who's willing to use a drone in a commercial aspect, all from the very low level inputs, where there is small drones flying in low altitudes in public areas, up to what we see on the picture here with large-scale drones flying from onshore facility to an offshore facility, a platform in the Norwegian Sea. So there is a very strong request from the community that they are allowed to do their exercises and their commercial aspects. There is increasing demand, and with demand there is increasing complexity. What we did previously with an air traffic controller, a pen and paper and email, is not working in a scalable outfit. We need to have a system in place to better handle this efficiently, but also safely for the air traffic controllers. This is the safety aspect here is very crucial. It is the step into UTM, but it accelerates into the efficiency as well. It's cost saving for us to have a UTM system instead of providing more air traffic controllers to the task. Implementing a UTM system will also allow us to do business development. The unmanned future is very exciting for us. We see every day new entrants into the airspace and new possibilities for Avinor and its customers to generate the business ideas. There is future rules and regulations that we have to follow as well. EASA just published the first rules around a UTM system. So doing a UTM system has been essential for us. We have chosen to go down a route with a software as a service with Frequentis in building our UTM system. The success factors for us has been the knowledge. We are a very experienced air navigation service provider, and Frequentis is a very experienced ATM provider. So the mixture of us, together with the subcontractor here, Altitude Angel, we feel is the right setup to be able to deliver the service that our customers want and the safety level and efficiency level that we need. We are both two trusted companies. We have preferred to do this as an option to see what can happen with UTM what can we build? What we're building today is a scalable system that will evolve into the future and provide much more services than we see today. We have a strong position, both the players. We are market leaders in our respective domains, and this is something that we build on when we do this. Going out to the drone operators, providing them with a solution, they are very, very happy to see that a strong company such as Avinor and such as Frequentis have done this together. We can provide them instant access to the airspace, and we can give them a tool that they actually want and request from us. When we have done this as a software as a service, it gives us a lot of flexibility and it's scalable. We don't know the future of UTM, we just know there is a future for UTM. So we wanted to build something that we can evolve, that we can develop in a very rapid process, so that we don't have to do the longer changes and we don't have a rigid system, so to say. When the drone environment is changing so rapidly, almost weekly or monthly basis, it is important that we have a system that can support that. We need to consider the safety aspects of it. We're not going to change our system every day or on a weekly basis, but we see the potential of a cloud-based service instead of a more traditional layout. Also important here will be the third-party integration. Roman mentioned in his presentation that, for instance, a police unit will be able to create no-fly zones or no drone zones. I think this is the future of UTM as well, that we will have more players into aviation that we previously had. If the police today want to shut down an airspace, they typically do it via a call to the ANSP in Norway, to Avinor. We then publish a note them and people are aware of it. With a UTM system, we are able to delegate this task to the police under rules and regulations, of course, but it also gives a bigger understanding or a better understanding for a lot of third-party operators who has not been involved in the UTM so far, or in aviation. So we see a huge potential here, and making this as a cloud service, it is easier for us to implement those type of solutions. Doing this, we have had a lot of lessons learned. We started early with UTM. We are sort of first movers in this area, along with Frequentis, and we have learned a lot, especially doing a project and deploying a project during COVID-19. Software as a service on a cloud-based structure has helped us here. We have done it as a step-by-step approach, where we want to build something, test it, learn from it, and deploy it. So it's very crucial, I think, to not grasp over everything with a UTM system in the start. You need to build step by step. The tech behind it is, I'm saying it's very much the same. It is not, but it's more of a general type of approach to it. But the people here is very important. You need to find people you can work with who has the relevant experience and can help you with the strengths you need in such a system. We have had a lot of early involvement with the UAS community, with the CAA and the air traffic controllers to be able to make such a great system as what Roman displayed here. What is important to know as well is that everything we do in UTM is a first off. The first rule and regulation was applied by or produced now by EASA just a couple of weeks ago. So everything we have done up to now is a first off. You need to make procedures, you need to have rules, training materials, safety assessments, and cybersecurity as a first off. There is no rules and requirements for this. You need to do it safe, and you need to do it so you have a reliable system. For Avinor, we will continue down this road. UTM is a strategic option for us. We will definitely stay in the UTM domain for a very long time in the future. We see the future roadmap from on our side is once we have a stable and efficient system for us to find a business development. The drone users will stop paying. This is in everyone's interest for the access to figure out how we want to do it and when we want it. There's large control airspace, but also very large possibilities for the ANSP or for other party users like the police, for instance. Sources, how do we monitor VFLOS, which is going to be the catalyst for the drone industry? How can we fly beyond visual line of sight on a regular basis with instant access to the airspace? We want to venture into automation and automatic operations. What we have today is capability of doing it automatically. This is already built into the system, but we want to do it, as mentioned, step by step. We want to prove that what we do today is safe, and then we implement new technologies into it. There's a lot of exciting use cases to be seen. for instance, the one where we delegate access to the UTM system to the police, as mentioned, third-party integrations here. The possibilities are endless almost for Asian perspective, and we are very keen to venture down this road and see what the future is like. So for Avinor, UTM is one of the strategic projects we are doing today to be able to do the aviation industry and the ANSP industry tomorrow. For us, this is the key going forward. Thank you, Roman.
Thank you very much. Thank you very much, Axel, for the very interesting insights. Ladies and gentlemen, we are at the end of our UTM presentation. Thank you very much for your attention, your interest. And I'm now handing over to my colleague, Michael Kupsch, who will give you some insights on the AIM portfolio.
Yes, thank you very much, Axel and Roman, for this interesting presentation, and welcome everyone to the AIM part of our presentation. ATM, UTM and other modern automation systems depend on aeronautical data to be able to provide their services. This aeronautical data comprises static data, for instance, restricted area, dynamic data, like for instance the activation status of a restricted area, weather data, and the ability to transmit flight plans. Traditional AIS systems provide all of this data in form of aeronautical information products. For instance, static data is provided via charts and AIP, dynamic data via the ICAO text NOTAM, weather data in the traditional alphanumeric codes formats, and flight plans, of course, in form of the ICAO flight plan. All of these information products are intended to be read by human beings. They are not entirely machine readable, which makes them unsuitable for the enhanced automation needs of a use-based service provider. Luckily, modern AIM systems address this need for machine readable data formats by providing data sets for static data, digital NOTAM for dynamic data, weather data in the IWXXM format, and flight plans in the FIXM format. I would now like to take a closer look at each of those new data and message formats and start with the data sets. A dataset is a defined collection of static data for a particular use case or application. In addition to the planned ICAO datasets, there might be additional datasets, for instance, for a drone management platform. This need for flexibility led us to implementing a framework in our AIXM 5.1 database, CADAS AIMDB, that enables us to configure arbitrary datasets. Such a dataset configuration can be thought of as a feature tree that starts from a root feature type and specifies incoming and outgoing references from and to other feature types and the properties that create the association. As an example, there could be an airport heliport which references its runways, the runways reference the runway directions, and so on. This way, we are able to provide just any data set with our solution. In addition, we also provide capabilities for exporting data sets that our customers already are used to from the normal export. For instance, we can provide dataset exports from the UI as well as from the system interface, and we can post-process the outputs using XXL transformations. Next, let's have a look at digital NOTAMs. The digital NOTAM brings several benefits over the ICAO text NOTAM. It stores all relevant information in a structured and therefore machine-readable way in the AIXM 5.1 data format. There is unambiguous linking of the digital NOTAM information to the underlying static data, and the digital NOTAM is transformable. This means the information in the digital NOTAM can be presented in different ways, for instance, in a map viewer. Digital NOTAMs are defined by the digital NOTAM specification. The specification identifies several digital NOTAM scenarios, For each of the scenarios, it provides ARXM 5.1 encoding rules, and it provides the automatic generation of ICAO text NOTAMs. This way, it enables a harmonized encoding of digital NOTAM events, it enables interoperability of different systems, and it enables the coexistence of digital NOTAM and the ICAO text NOTAM. So now that we covered the basics, let's have a closer look at what the Frequentis digital NOTAM solution looks like. Our digital NOTAM solution is based on our proven COTS components, namely the CADAS ARMDB for ARXM 5.1 data management, as the digital NOTAM is of course based on ARXM 5.1, and our CADAS IMS, our ICAO text NOTAM office solution, to be able to transmit the ICAO text NOTAM to the aeronautical fixed network. In addition, there's also a new component, which is the Data Originator web portal. The Data Originator web portal is a web-based front end that is specifically intended to create digital NOTAM proposals. A data originator would create such a digital NOTAM proposals via the Data Originator web portal. This digital NOTAM proposal is then sent to CADAS ARMDB to be able to be verified by a professional operator. And if approved, the automatically created ICAO text NOTAM is sent out via CADAS IMS to the aeronautical fixed network. The digital NOTAM is sent directly from CADAS ARMDB to a SWIM system. As the Data Originator web portal is the new component in this setup, let's have a closer look at it. The Data Originator web portal is a web-based, map-centric front end to create digital NOTAM proposals. It can use any map from common map providers like OpenStreetMap or Google Maps as a background and displays aeronautical static data stored in CADAS ARMDB on top of this background map. To create a new digital NOTAM proposal, the Data Originator would select the digital NOTAM scenario. In this case, it's a runway closure, and would then define the event validity and the airport. Afterwards, the map centers on the airport and enables the graphical selection of the runway to close. As an alternative, the runway can also be selected from the menu on the left side. After defining a reason for the runway closure, our digital NOTAM is already good to go and can be sent to the operator for verification. A similarly simple workflow is possible even if multiple static data items are affected. For instance, if we have a taxiway closure which affects several taxiway elements. In addition, the Data Originator web portal also supports our Data Originator when creating a schedule by visualizing the schedule for visual verification. Also, it is possible to preview the ICAO text NOTAM as well as the digital NOTAM at any time during the creation process. The importance of digital NOTAM for a use-based service provider is evident, but there are also scenarios that require a use-based service provider to create a new digital NOTAM. For instance, to restrict any traffic from a certain area because there's a drone flight, for instance, for infrastructure inspection, for police intervention or search and rescue activities. Our digital NOTAM solution is prepared for this as well, as it provides system interfaces that enable external systems to create digital NOTAM proposals as well. The digital NOTAM specification I mentioned earlier is a work in progress. Nevertheless, we already support all of the digital NOTAM scenarios that are listed on this slide. In the course of the next 12 months, the number of supported scenarios will double. Last but not least, let's have a quick look at the new message formats for weather and flight plan messages. The IWXXM format and the FIXM message format. Both new message formats address the need for more detailed and less error-prone data formats that shall also be machine-readable. In the future, they will replace the current TAC and ICAO FPL messages. Due to the long system life cycles in our domain, an ANSP might run into the problem that a legacy system needs to be kept operational even past the deadline to switch to the new message formats, or a new system shall be commissioned which doesn't support the legacy formats anymore. Both problems can be solved with our message converter. Based on our market-leading message switch AIDA-NG and our messaging solution CADAS ATS, we are able to provide a message converter that supports converting legacy messages to the new formats and the other way around for both weather and FPL messages. The conversion process is fully automated and only requires human intervention in case a broken message is received. To sum up, with the new message converter with digital NOTAM and the datasets, Frequentis AIM is prepared to support any new automation system. We are ready for the new normal and we are looking forward to new exciting projects with you. I would like to thank you for your attention and hand you over to my colleague Ulrich Kage, who will present to you the glue that sticks all the new exciting systems together, the Mosaic Swim. Thank you very much.
So, hello everybody, this is Ulrich Kage speaking. I'm the Swim Solution Consultant and I would like to talk a little bit about Swim. You've heard about the UTM technologies, the AIM technologies. UTM is very fast-paced, it's a disruptive technology. AIM has been around for for many years actually. Here we are not so fast-paced because of the long system lifetimes, but both of these, they need to digitize their information so that it can be processed automatically. And it's clear that today's communication networks are not fit for digital data. So that's why the SWIM concept was introduced, and you might know this figure. It's presents the SWIM concept in contrast to the UTM and AIM, which is more on the application layer, which is the top layer. SWIM is more behind the curtain. It's a service-oriented architecture with a registry that is meant to replace the current communication infrastructure, which is based on AFDN, Aeronautical Fixed Telecommunication Network, or AMHS, and is not really fit for these new data and is not fit really for automation. So we focused on the SWIM layer here, and we put this SWIM layer into a product. This product is called Mosaics, and as I will show you, Mosaics is more than just a communication layer. In the next slide we see that Mosaics is there not just to integrate, but to connect all kinds of systems. Is it the Frequentis portfolio on the left side you see? Is it connectivity to third-party products, to other customers, to organizations outside of an ANSP? Mosaics is there to connect everyone. And it's not just, as I said, a communication layer, it's also a deployment platform. It's an ATM-grade internet technology. So it's ED 153 compliant. You can deploy it on premises, in a cloud, in a private cloud, public cloud, Microsoft Azure, Amazon Web Service, whatever you like. It provides open interfaces for connectivity, which is very important to avoid a vendor login. Yeah. And last but not least, it's compliant to the SWIM concept, to the SWIM technical infrastructure. It supports the yellow profile. It has a SWIM registry, a rich set of converters I will come to in a later slide in more detail. And it's a microservice-based architecture, so you can easily deploy additional microservices. This is important to keep track with the fast pace of today's IT developments in the UTM and in the ATM domain. So, so you might say, okay, this is great, but what benefit do I have over the typical IT components like Kubernetes, like an enterprise service bus, or any message broker that is available on the market? And yeah, the difference actually is, if you look at this figure where the ATM-specific functionalities are on the x-axis and the UTM-specific functionalities on the y-axis, you will find that commercial enterprise service bus or message brokers, they only come with very limited UTM, ATM-specific functionality. In contrast, Mosaic Swim already has a wealth of services implemented that will jumpstart your Swim infrastructure immediately. To look into a little bit more detail, from top to down, we have the data sources that ingest data, we have applications that request the data, and Mosaic Swim provides everything that is required underneath, from security layers, API managers, a message broker, the service registry, which is, by the way, not typically included in a commercial off-the-shelf message broker, a visual data mediator to resolve conflicts if there are any, and identity provider for authentication, identification, a data store, and of course monitoring and logging. So this is already ATM graded and directly available, but that's not all. Included also is a number of ATM services we implemented for weather, for flight planning, airspace and surveillance, and UTM services. So as you can see, this is not just a technical infrastructure, it's the technical infrastructure for your ATM or UTM technical infrastructure. So if you have Mosaic Swim, you're ready for the new normal to implement all these digital data formats. But it's clear the legacy systems, they still exist. They have long system lifetimes. AFT and AMHS is still the worldwide network. So what you need in addition to this is also some connectivity to the legacy infrastructure, which is messaging-based AFT and AMHS. And here we also have a solution. We have the AMHS Swim Gateway, which is a bridge from the old to the new normal. The incoming AMHS messages, which are based on X400 protocols, can be repacked into AMQP messages and provided directly into the Swim infrastructure. Of course, you might say, okay, I have an infrastructure, I have new services. What shall I do with the ICAO Doc 444 for flight plan messages? I would like to have fixed them. So then we can extend this whole infrastructure, not only with a gateway, but also with implied conversion, as Michael already addressed in one of his previous slides. So whatever you receive through the AMHS network, NOTA, MED, flight planning, whatever you can convert into the new formats and provide it to the data consumers in your Swim network. So the Swim TI and the gateway, these are the main pillars of the new technical infrastructure. And I would just like to give you two examples how we help customers to quickly implement this new technology and to solve their problems. I've been working in the ARM domain for 15 years, and there are still some issues. Let's say ARM on one hand has new digital data, but consumers still, maybe from other vendors, they are not at the end of their system lifetime. They have their proprietary formats for configuration data and the like. So here we have the typical problem that these systems are not connected. So turning or taking the AIM information is through the AIP, typing in or copy-pasting information as, to make it the configuration data of the ATC automation system. And with all these kind of problems that arise, like coordinates are in the wrong format, let long let, whatever, you can look into it and you will find lots of issues you have with this, data chain. So what we did is we swimified the applications. Our AIM solution is already SWIM compliant, so we work together with a third-party vendor for the ATC automation system, and we created with a SWIM TI, we created a technical infrastructure where we automatically feed the ATC system with the AIM data. And what was amazing is that it was basically so easy to swimify an external application and make it work in the new SWIM environment. This is one example. The other example, if you look at the sad smileys or saddies on the left side, of course, this new solution is puts a smile on everybody's face who has to work with it. So this is just one example. The next example is more complex. If you look at that picture, it's a common information service. This is the UTM system we are building, which Roman talked about. And I don't want to go into all the details, but one detail is important, this one. If you look at the core of the system, what we use here as a technical infrastructure, as a product that communicates, is the SWIM technical infrastructure that we use here. This is the Mosaic SWIM. So it's the same infrastructure we propose to our ATM customers. It's already being used in UTM. And this is not by happenstance. This is because this infrastructure provides all the technical framework that you need for automation. And we know in the UTM world, it's all about automation. What we talked for years, what we would like to have in the ATM domain, is already there in the UTM domain. But the good message is, it's not, for us, it's not two worlds. It's, if you like, one infrastructure that can be used in the ATM environment as well in the UTM environment. Okay? So this was my short presentation about SWIM. It's more kind of a teaser. So if you would like to learn more, don't hesitate to contact me. And to sum up, what we showed here in this presentation, in this stream, is the connection of all three domains, UTM, AIM, SWIM, how we enable technology to work together and form something new, something complete, which can be used in domains like UTM, which are fast-paced, and also in the ATM domain, which is a little bit slower maybe, but for a reason. Okay? So thank you very much for your attention, and I would like to hand back to Marcus.
Yeah, thanks, Uli. It's amazing to see this example of what digitalization in ATM really means. And UTM is really the driver, AIM is the enabler, and SWIM is the glue for it. You said it yourself. 2 questions or 3 questions that I have from the chat and a few more questions from the email. And I would like to start the questions addressed to Axel Knudsen, because I know that he has commitments, time commitments. So the first question is regarding Avinor. How does Avinor manage unexpected operations in the airspace using this system?
Thank you, Marcus. We use this system for the planned missions, so to say, the ones who are willing to declare where they want to fly and how they want to fly. If we assume here that unexpected is unlawful, we don't use the system, so to say. We have the possibility to integrate counter UAS into the system, and we will probably do that down the line. If I read the question to be how do I use this system for unexpected, like instantly someone wants to fly, then yes, it is capable to do that. You can file a flight plan via the system and receive an answer within seconds or minutes. So we are able to cope with unexpected operations using this system.
Okay, truly automated, or basically autonomous almost. Another question to you, I think, and maybe also Roman wants to mention that, is the portal certified by the National Safety Agency, NSA, what was it in the chat, the National Safety Agency, to provide aeronautical information?
I have some trouble with the sound now, Marcus. I'm not sure if I got your question there. I couldn't hear what you said. Was this a question related to the National Safety Agency to provide aeronautical information? If so, then Avinor is yes, we are allowed to provide aeronautical information service as an ANSP. We use various platforms to do this, either the ATM system, either a SOL system separately, which is a website to the airspace users called ippc.no. And we use the UTM system as well. We use the EAD data that we already have to provide into the system. So all the users using our system will be able to have the AIS notifications in the UTM, or they could use other sources we have. So yes, we can do that. It is not verified by the CEA. We have the approval process with them so far, but we expect this to be completed within 1 or 2 weeks.
Okay, that's awesome. Thanks, Axel. Meanwhile, please put your questions into the chat or put it into invitation@frequentis.com so we can get them. I have, in the meantime, one more question regarding ARM. And I think if there are no questions to Axel, I would like to say thank you to Axel. Thank you for joining. I know you have another appointment following this one here. So thanks for being with us here today. The question regarding ARM is the data origin at the web portal certified as well by CAA, or it has to be?
Knowledge, it has to be certified, but I can look it up and get back to this later on as well.
Okay, so we're gonna stay in contact with Uros. The question is coming from him. I see your name here. So we're gonna stay in contact. I think that's important. If we're not able to answer all questions, we certainly send us your email, and we're gonna get in contact with you either directly or through your regular Frequentis contact here. I have another one for SWIM, and that's an interesting one for the SWIM development. And I've been personally involved in SWIM for some time previously, having worked with the early concepts. So SWIM concepts have been around for 10 years already. Why is it progressing so slow and not already implemented worldwide yet? And that's a question to Uli.
Thank you, Marcus, for this question. It's an interesting question because I'm asking this question myself. I've been around in the ARM domain for 15 years, and yeah, we are talking about SWIM for 10 years already, roughly. Yeah. So, and that's right. So my understanding is we have two problems. One is the long system lifetimes. If you procure a system now, it's a huge investment, and you keep running it as long as you can. Yeah. And it's clear a system that runs today has been maybe designed 10 or 15 years ago or even longer. So it's not like in the UTM where it's so fast-paced, it's up to date already and implements all the necessary interfaces and technologies. It's also a technology question. Yeah. The other aspect is, of course, the standardization. Yeah. If you think about your laptop today, you can connect it anywhere you are, to a wireless, to a wired connection, whatever. You can do this because we have really strict standards, so there's no deviation. Similar standardization level we have in the AMHS and AFDN world, yeah? But not yet, unfortunately, in the SWIM world. Their standards are not as strict as they have to be, so that if I take the standard and implement it, I'm automatically compliant to another vendor who takes the standard and implements it. There are variations in the data formats, in the data interpretation, in the interfaces, basically on each level. And this, I think, is where we have to work quicker and provide more strict standards so that we can build upon this. And this has to be first. Only if we have the standards, then also a company really dares to invest a lot of money to implement or develop such products. Yeah? So this is maybe one of the, or two of the reasons why it doesn't happen faster.
Hoping it's not taking another 10 years from now. And I'm sure we are pushing this and trying to make sure the information is out there, because the technology is ready. It's somewhere else where we see that. So that brings me actually to the close of this session. I'd like to say thank you all to my amazing speakers. Once again, thanks to Axel for being with us here from Norway. My speakers, again, they were from Frequentis Comsoft in Karlsruhe, they were in Vienna, in Norway. Please hit the like button if you like what you've seen. Subscribe to our YouTube channel, and for follow-ups, questions, get in contact with your local sales Frequentis point of contact. The next session will start in about 1.5 hours if you would like to join. It is about increasing efficiency and resiliency in virtual centers. You can join using the same link, so just tune in at 2 p.m. Central European time. That's in about 19 minutes from now. And with that said, have a great day. Enjoy the rest of your day. Bye-bye.
Guten Abend, Austrian 180 Sierra, out of 220 descending 150.
Austin 180 Sierra, guten Abend, information Whiskey, expect a less 16 no speed restrictions, direct Wagram.
Danke, direct Wagram, Whiskey on board, V180 Sierra.
Seagull 102, descend 2500 feet.
2500, Seagull 102.
Seagull 102 to make it short, gets 2500 feet.
2500 feet, 10.
Seagull 102, turn left heading 230.
Left 20, Seagull 102.
Field radar, Iberia 3575, good evening, leaving 4000.
Iberia 3575, good evening, identified, campfire level 170.
Landing 170, Iberia 3575. Good afternoon, from 2039, about.
Good evening, standby, Seagull 102, left 180, clear the left 16, report established.
180, like great, 102.
12039, good evening, identified, campfire level 240.
Landing 240,
Foxtrot 477 Echo, contact speed 13435, goodbye.
13435, goodbye, 477 Echo.
Public traffic, Seagull 102.
Seagull 102, confirm established.
Affirmative.
Thank you, contact tower 119 at decimal 4, good night.
1194, 102, good night.
Iberia 3575, proceed after Soleno, direct Denza.
After Soleno, Denza, Iberia 3575.
2039, direct Sydney.
Direct Sydney, 2039.
Tirol 78 Victor, contact speed 13435, servus. 13435, 78 Victor, servus. Tirol 58 Kilo, contact Wiener Räder 133 decimal 8, servus.
In radar, good evening, CSA 607, heading 030.
3607, good evening, identified, campfire level 160.
Ground level 160, CSA 607.
Austin 459, 2700, climbing 5000.
Austin 459, guten Abend, identified, campfire level 240. 78 Victor, direct Rattenberg.
Direct Rattenberg, Tirol 78 Victor, Dankeschön.
Guten Abend, Austrian 180 Sierra, out of 220 descending 150.
Austin 180.
Hello viewers and welcome back to the 2021 edition of Frequentis Connect, the place to be for ATM professionals this week and today. This is our unique and exclusive live event for you to update you about the latest and greatest what's happening around Frequentis and ATM. Today is really a special day. Today, March 10, is normally the day where we would all meet in Madrid, where we do networking, where we do exchange of thoughts, discussions, also have fun. This is going to happen in October, World ATM Congress in Madrid is happening in October this year, but now we are here, Frequentis Connect. We have ourselves, we've got ourselves 5 sessions. Now this is the 4th session of today. Those who are rejoin us, yeah, thanks again for joining, and those new, I would like to welcome you all from where you are. I'm using the chat here. I'm looking down here. I'm seeing the chat on YouTube to welcome you all here. Just put into the chat from where you are. We are really interested to know how you feel and if you're all feeling good and excited and want to get involved. And let us know from where you're joining this call. Yeah, 2021, certainly different. We are heading into a new normal. For aviation, the traffic levels are nowhere near where we all want them to be, that is for sure. But there's definitely also positive signs ahead of us. For instance, the CDC in the US, they just recently declared that people can meet in private, vaccinated people can meet in private without wearing masks and without social distancing. And when I get pictures from friends from Australia or New Zealand, they almost have a normal life there. And this is really awesome. So there is positive signs ahead of us. Of course, we still have to work on this recovery. We still have to work on setting the priorities right. Yeah, this is great. So hello in the chat. Hello to Vienna, from Vienna. Hello to the Philippines. Awesome that you're all joining here. Really looking forward to you guys. 5 o'clock in the morning. Hey, welcome. You're here. I hope you have a good coffee at your place, Gary. That is cool. Glad to be here. Glad to have you here, actually. So this new normal, what it's all about? Number one, it's about digitalization, but not just systems, but also about processes and about getting things into more automated ways, assisting the controllers in their work and connecting the bits and pieces together. The other aspect of the new normal is definitely green aviation. There needs to be more and more focus on environmental friendly systems, on environmental friendly aviation as such, optimal flight profiles, saving fuel, but also not having to build structures anymore which are no longer necessary. So these are aspects that we certainly want to discuss. We use the chat here, and we have more people from Estonia and from Germany in that call, and I'm really happy we have almost 400 registrations for this call here. I don't see yet how many, there is lots of people actually live, and there's probably a lot more people joining at a later stage when they rewind and rewatch this session here. So I'm really glad that you're all here. This discussion now is the next slot, and let's get into it. It's about increasing efficiency and resiliency in virtual centers. And there are 4 great speakers here. The first one is Daniel Kobosch-Meja. He is the solution consultant for surveillance. Then I'm glad to have here Didi Pfaff. He's a solution consultant for ATM systems. Both of them are joining from Frequentis Comsoft in Karlsruhe in Germany. Then I have Michael Ellinger, strategic product manager for the remote digital tower system. And as a very special guest, I would like to say welcome to Frank Christensen. He's the manager of project planning and execution from Navia in Denmark. And he's going to talk about how they are doing it in Germany, in Billund there. So before we get started, once again, the reminder for questions, please use the YouTube chat. And I see that the chat is already going on. Hello, Adrian. Hello, Jan from Estonia. I hope you're all doing good. Gogo Alexandru from Romania, Romatza, welcome that you are here. The chat is public, so please observe that. If you prefer a more private option to get in contact with us, there is the email contact, and my colleague will post it in the chat, invitation@frequentis.com. We are also observing this, so you can also put questions there. We make sure that we answer them at the end of the session. It's going to take about 1 hour, this session. We try to make sure to be ready on time with that. I know that your time is really precious, and that we need to stick to the timing here. So, yeah, without further ado, I would like to hand over to Daniel, actually, to Karlsruhe. How are you? Hope you're doing fine.
Hi, thank you, Frank. Good afternoon, good morning, good evening elsewhere. Yes, my name is Daniel Kobosch-Meja. I am the solution consultant for the... Yes? I am the solution consultant for the surveillance solutions in the Frequentis group. And before we step on the matter of our presentation today, ATM centers, I would like to take you through our surveillance portfolio. We have a broad surveillance portfolio, which is ranging from sensors, passing through the distribution systems, the surveillance data processing systems, and finally the place where all the magic comes on, and this is the control working position. This is a part of the Prisma solution. My colleague Diri will give you an insight on it after my participation in this webinar. Yeah, without more preamble, let's begin. Let's talk about our surveillance solutions. Our sensors, our product is called Quadrant. Quadrant is an ATM-grade multilateration and ADS-B sensor. The system is one of the main characteristics I want to tell you today is that the system has a dual use. It could be deployed for ADS-B surveillance, or it can be deployed for multilateration. We using the same architecture, the same hardware, so that the ground stations are common for the both technologies. That enables our customers to have a seamless transition from a simple ADS-B constellation. By adding more ground stations, we will keep increasing the surveillance coverage until we have the enough ground stations to provide multilateration. As I say, this is a seamless process. We would need only to do minor updates on the Quadrant central processor to pass from an ADS-B installation to a multilateration. The system is complying with the European standardization. We follow closely the Eurocade performance requirements, and we keep our solution Quadrant up to date to the newest releases of those specifications. Why multilateration? Multilateration has only benefits when you compare it with the conventional rotating sensors, such as conventional radars. The use case, it might be the same, so you have the same benefits from these old technologies, but when we talk about multilateration, we have some additional benefits, like, for example, a high update rate interval that is needed when we have to provide ATS services in approach airspaces or in surface movement. The initial investment can be a fraction of what a radar installation could be. Although we need to deploy ground stations in multiple locations, we try always to partnership with local infrastructure providers, telecommunication providers in the country, to have multiple options. Is another reason for going with multilateration. Nowadays, there are busier spaces that are dealing with the high amount of interrogations in the 1090 megahertz frequency, and the RF footprint can be drastically reduced when you use our solution, our Quadrant solution, because the system can interrogate only in the area where the target is expected to be, and not all over the airspace. And I think it's also worth to mention, we have some highlights in our Quadrant solution. For example, GNSS outage resilience. For multilateration, to be able to provide an accurate positioning of the targets. The system talk about multilateration systems for a small area, for example, in an airport. The synchronization between the ground stations can be easily reached out through the network, so with NTP servers. But when we go beyond that limits, and we speak about wide area multilateration systems, we need to rely only on the GPS signaling for the time synchronization on the ground stations. And yeah, the GPS service is about we have on this matter and developed with the cooperation of our local the Karlsruhe Institute of Technology. In sync even upon GNSS outages for long period of times. Most of the multilateration manufacturers, they claim to have for with our mechanisms. And other highlights like ADSB, anti-spoofing. In ADSB, you rely entirely on what the aircraft is telling you, and the system should be ready to detect if those transmissions are actually not from aircraft, but so from some other sources. Sabotage, high precision timestamping, and the list goes on. This is a handful of our success stories of Quadrant. We have installations all over the world. Some of them are ADSB installations systems, and either at local, so local area, or wide area multilateration, country-wide deployment, like for example in Denmark. And this is the slide you see now on the screen. We have deployed with only 32 sensors a nationwide multilateration service, which goes actually beyond the continent over the North Sea. We can see over 100 nautical miles beyond the coastline, and only using onshore ground stations. This is a very interesting deployment. We have the luck to come today with a guest speaker from Navier who probably can expand. The next subsystems in the surveillance data chain. Surveillance data. SDDS of data. The system takes the info to convert it into IP. Converting IP, then you surveillance data is increasing and increasing. It's not just the ATC units, but also air defense organizations, airlines, environmental agencies that are requiring surveillance data. And the idea here is that all the surveillance data is in a network, in a cloud, and the user just need to connect to that cloud to get this service, to get the surveillance data. You as operator, you have the possibility to define what that user is becoming. It might be only, for example, in the case of a military unit, it would be only primary information, and even you can extract only the primary information from a combined radar and deliver only this segment of multilateration systems that require probably the location of ground stations in the country, so each of these can be connected to the nearest node of this cloud, of this. What I'm saying, you have a surveillance service network, is the interconnection of the different SDDSNG, the different nodes, and you have all the sensors and the multi-sensor information as well in that network, and all the users demanding the information from that network in a secure way. This is a sample of our happy customers with SDDSNG. Some of them are only surveillance data front-end processor, others are a complete nationwide surveillance network, like the case of we have deployed for them 26 nodes in 4 sites, and more than 200 different users are accessing to this network of surveillance data to obtain their service. And last but not least is the data fusion and tracking. We have built upon 20 years of experience of being the main industrial partner of Eurocontrol for the development and the provision, maintenance of the Eurocontrol tracker, the ARTA system, and we have made use of all this experience to have our in-house solution, our own system called MSDF, Multi-Sensor Data Fusion. It's a tracker which is focusing on diverse fields of applications from the standard ATC, APP, and upper airspace control to SMGCS, EU space, remote digital towers. So we're focusing mainly on all the possible use cases. And with the possibility to process practically any kind of surveillance sensor, from the conventional ones, multilateration, ADSB, external trackers also that can be connected to the multi-sensor data fusion, and then the system amalgamates this information with the own air situation picture that is produced by the MSDF, so to have an extended view of the situation up there. And as I said before, we are the main industrial partner of Eurocontrol for the maintenance of the ARTA system. We offer ARTA's rollout projects worldwide. It's not limited to the Eurocontrol member states, but we have deployed ARTA systems in other countries like United Arab Emirates, in Qatar, in Indonesia, recently in the US. And the system, we accompany the customer through service level agreements to keep the tracker, either ARTAS or MSDF, tuned because the surveillance sensor is very dynamic and it requires continuous tune-up. We offer also training services for ARTAS at factory or on-site. We have basic and fine-tuning SAS evaluations to see if the SDPS, ARTAS or MSDF is meeting the Eurocontrol SASP's performance requirements. And yeah, we are here in Karlsruhe. I very much look forward to hear from you any question, any consultation on surveillance, on the surveillance solutions. And I will hand over now the stage to my colleague Didi, who will tell you, who will continue in the surveillance data chain process with our Prisma solution, which is actually the control working position where all the surveillance information is presented. So, Didi, when you want.
So, thank you, Daniel. Yeah, well, it's me now to close the loop of what is called the surveillance data chain. Let us spare some time to look at the air traffic management solution of Frequentis Comsoft, the Prisma system. Well, as Daniel mentioned and explained, in the surveillance data chain, from sensors through distribution, through processing, on the display side, air traffic controllers needs an air traffic management system to safeguard the traffic in the air. The solution of Frequentis Comsoft and the Frequentis Group is the Prisma air traffic management system. It is a fully functional, state-of-the-art ATM system. It's a field-proven system installed in sites where we see a very dense air traffic situation. Typically, an air traffic management system consists of several components. You could call it modules, just to name them: flight data processing system, safety nets, and the controller working position where the air traffic controllers do their job. Well, the Prisma system is compliant to ICAO and Eurocontrol standards, of course. There is a constant ongoing development to align the system with the future operational demands just to mention the ICAO ASBUs and the CESA virtual center concept. Let me just move on and show you some of the use cases, not all of them because time is restricted. Let's have a look on the tower and the remote tower where Prisma has its role, also to approach centers and area control centers. Well, due to restricted times, I have selected just a few points that underline our main topic today, increasing efficiency and resiliency. Let me start with the enhanced situational awareness, what we can see in the top bottom corner and the left corner. Well, the Prisma Air Situation Display, one of the modules of Prisma, is enhancing the situational awareness of a tower controller. So typically a tower controller has a view outside of the glass window, or in case of a remote tower, he gets a view supplied by cameras. With the air situation display, the air traffic controllers has an enhanced view beyond what he could see looking out of the window. For a second point, the optimized resource management. Well, here I just pick one feature out of many, and it's a traffic forecast. Imagine that the Prisma system has a feature where the traffic is forecasted not for the next few minutes but for the next hours. That way you can balance the number of air traffic controllers needed for the next hours. So it's a real handy tool to optimize the stuff needed. And well, talking about air traffic controllers, we have surveyed and asked them what do they like most in Prisma in the solution. And what we get as a feedback is on the one hand, they really enjoy the possibilities to customize the HMI, their working area, and also the intuitive use of the HMI. And secondly, and that's our topic of today when we talk about efficiency, the Prisma system, the HMI, offers for the most routine task, approximately 80% of the routine tasks can be achieved by a single mouse click or pressing a hotkey on the keyboard. That way, the air traffic controller is relieved from these routine things, these tedious things, and can concentrate to deconflict situations in the air to avoid that safety net alarms pops up. Well, let me come to the point number 3, the increased resilience with contingency and backup. Let me spare a word to COVID-19, the pandemic situation. We all noticed that the number of travelers dropped dramatically. We see some hopes, we see some signs on the horizon that this will get better. However, even in times of low traffic, one thing stays, and this is that air traffic services must be available 24/7 year-round. So, as recognized by several ICAO regional ATM contingency plans, and here I quote the plans, they say, system redundancy is the most effective contingency capability. So Prisma, coming back to Prisma, can be deployed as a backup and contingency facility, and I will, in my next slide, go a little bit more into detail here. One point, though, I would like to mention. Imagine that the main ATM system and the backup system are from the same vendor. There's a risk embedded in this setup. The risk is, if there's a severe software failure on the main ATM system, this might be promulgated to the backup system, which is of the same vendor, leading to the most feared ATC 0. That means, in worst case, the air traffic controller sits at a black screen in the main system, switching over to the backup system, same black screen. To overcome this risk, it is important that ANSPs decide for a backup system that is dissimilar to the main ATC system, just to reduce the chances of such an ATC0? Well, let's go to Prisma ACC contingency backup system. Let's look at a sample configuration where we have typically a server pair of a master and hot standby configuration, and we have interfaces towards the outside world. In this sample configuration, I have selected a connection to AFTN AMHS to receive flight plans, a connection to an oldie gateway to exchange electronic coordination messages to adjacent senders, and particularly interesting for our backup system, a gateway to the main ACC system to receive system flight plan updates from the main system into the backup system so that the backup system is ready to take over anytime. Additionally, what is needed is the surveillance data. As Daniel perfectly explained to us, there's a whole chain from sensors through distribution, through processing, up to the air traffic management system. In this sample configuration, we see asterisk data, surveillance data coming from a surveillance data processor system, be it an MSDF or the ATAS or anyone else. Towards the front end, towards the controller working positions, we typically see a setup where an executive controller and a planner controller work together as a team, as a duo, working on one or more sectors. With a supervisory position, we have the possibility in Prisma to dynamically adjust the sectors to controller working positions. That way ensures that there is a good balance between number of air traffic controllers and traffic controlled, air traffic controlled. What we see here in this sample configuration is a very typical setup, what we could call a co-located configuration, where the backup system and the main ATM system are on the same side. With Prisma, we can go a step further. Imagine a centralized approach where two or more ACCs in one country share a common backup system. This is possible with Prisma. And finally, even one step further, a common shared backup system across ACCs internationally with a sharing backup system shared by several ACCs in several countries. Finally, I will come to my last slide, Prisma use case as approach control center. We have a sample configuration here. Looks pretty much similar what we have seen with the backup system. We have the back-end server capabilities. We have connections to the outside world. What is maybe interesting for an approach control system that the safety net is dedicated to time-critical narrow airspace, which requires a quick and easy decision making. Excuse me. Of course, controller working positions are assigned to the specific task of an approach control system. Well, I think I'm coming to the end. I would like now to hand over to Frank Knut Christensen. Markus Klopf has already introduced him. He is manager of project planning and execution at Naviair in Denmark, and Naviair we are right now in rollout to supply an approach control system together with a remote tower project to Naviair, and I'm really glad to have Frank on board here to give us some insights on that. So handing over to Denmark.
Thank you very much, Didi, and as time is limited, I will jump directly into the presentation. And now my computer is frozen. I hope you can see the slide has changed now and you are in. The reason Naviair went into remote tower is basically that we thought that there was the need of a new mission. There was a need of investment in the infrastructure of the Danish airspace and the airports. We needed also to be more flexible towards our customers, both the airports, which are current our customers, but also coming. And then we also have a challenge that the regional airports, they are hard pressed. That was even before Corona. Now is much worse, of course. So we need somehow to find a way to make our services even cheaper while still maintaining both flexibility and safety and reliability. And therefore, in essence, raise our effectiveness. We also saw that the remote tower with the visual presentation on screens gave the opportunity to actually potentially increase the safety level in airports by introducing visual safety nets and also, of course, the use of infrared cameras. Today, the airspace in Denmark, which is a rather small country, 300 kilometers sort of from north to south and from east to west, it's very fragmented. We have a TMA in the east, which is aiming for Copenhagen Airport. And then we have a lot of local traffic areas for each of the regional airports in the west. Some of them are only AFIs and not really air traffic controlled airports. Some are purely military, and one is combined civil and military. So it's a very sort of mixed picture. And the sort of the vision, the future vision there is basically to have two large TMA areas, one in the west and one in the east. And therefore, it was decided to aim for trying to establish a common remote tower and approach center in the western part of Denmark, more specifically in Billund Airport. So basically, the timeline for our program has been that in 2016, Navia and also the Ministry of Transport, they went into sort of strategic considerations regarding this issue, and that resulted in a new aviation strategy for Denmark in 2017. Then the 2017 was otherwise used for technology evaluation, including a formal technical dialogue where we invited the four main suppliers of RTS systems to present their technology. It was not a dialogue intended to end with a purchase, but just to collect information and thereby enabling us to prepare in 2018 for a specific tender. And that was conducted in the year 2019, and everything looked good going into 2020. So we signed a contract, and then everything stopped, as you are well aware. We had this Corona freeze, and everything was questioned. I mean, the economy of the business, our customers' economy, the airspace users, everything in the value chain was basically under tremendous pressure, and that is still the fact. I think in Danish airspace alone, we have lost something like 75% of our traffic. I just got the figures that all of the passengers going through Copenhagen Airport in February is the equivalent of what was coming through the airport in one single day the year before. So it's a huge loss. Nevertheless, Frequentis showed here, I would like to really appreciate that they showed flexibility and creativity in coming up with a plan which enabled us to sort of utilize a phase where we had to freeze the actual project simply because we had to look into all of our investments and reprioritize investments and reschedule some, but also because we had to adjust the workforce in Navia, and there has been a very huge adjustment downwards due to this. And that, of course, is a momentous challenge in a business where a huge, quick reductions in workforce in the air traffic control area is not the norm. Nevertheless, we're looking into vaccines, which is very nice. They are rolling out, maybe not fast enough, but they are coming. So in January, the board of Navia decided to unfreeze again, and we are now in the phase where we, together with Frequentis, are designing the details of the RTS system. and also looking at defining the exact location of and sort of type of airport infrastructure needed. And as you can see, I have tried to illustrate it with a drawing at the bottom, where you can see sort of a pavilion which is going to be erected next to the existing tower building. Due to the corona and due to the very uncertain economy at the regional airports and in the business as a total, starting to design a permanent building for a specific number of airports is judged too risky financially at this time. So we will start with a temporary installation in a pavilion, which we expect will be there for at least 5 years. Then in the coming years, it will basically be about verification and validation of the RTS system installation and the training of air traffic controllers and achieving regulator approval. And then I think the actual day where we will go into operations is likely to be very early 2024. The fact that we had to reduce the number of air traffic controllers in Naviair to such an extent that meant that getting all the air traffic controllers trained while they're still maintaining the traffic in the existing tower, that simply is a longer process. So that is judged to take at least 9 months. This is why the go live date has moved 1 year, even though we have only had a corona freeze in the program for half a year, basically from summer to January. So this is sort of the timeline for the first airport, Billund, and it may sound strange that we are going to implement a remote tower in Billund from Billund, but that is because the intention is that Billund will be the first airport, and it is as such also a showcase for the other airports, not the least the military airports, where there of course are great concerns to give up a military airbase. I think what we have, if we look at the solution here, you can see there's actually an operational room, an ops room to the left with its own technical room, and then there is to the right the test trainer and contingency facility with the exact same equipment and also its own technical equipment behind. And this is actually quite easily then extended to handling 2 airports. That would only require that a test training and contingency facility would be established at some other location. So this gives a good flexibility to this solution. Finally, this is basically the Frequentis solution Naviair has decided to procure. We will have, of course, a panorama consisting of 5 large 65-inch screens in landscape mode. And I think that is there has been discussion in the community what is best, landscape or portrait mode, and how big should it be. We have come up with this decision that we see this as the most sort of future-proof version, because the intention is in Naviair that in the long run we will look at trying to see if we can establish multiple operations. And the solutions we have seen so far regarding multiple operations of airports, having the OTV on top of each other in landscape mode seems to be the most elegant. And the airports that Naviair decides to use remote tower for are the largest airports in Denmark. It is not smaller airports. So solutions where you basically only look at one airport and then have to sort of call up the other in case you have traffic there, that is not regarded as the optimum solution. We have then 2 remote tower positions sharing, or controller working positions sharing one panorama, and they have an info layer with a Prisma screen also. because during the nighttime, it is actually the intention that the approach to the airport is also handled by the tower air traffic controller. They have a dual rating. In the daytime or during peak hours, it is the intention that the approach is handled from specific approach module positions, as you can see in the front, at the bottom here of the slide. And in the future, when we hope we can establish this common approach, they may then move into a separate location at that point. But at the moment, it is intended that the approach modules are situated in the same room, maybe visually shielded or audially shielded from the remote tower module, but nevertheless sitting in the same room. So this is basically, I think, a very quick introduction of the remote tower program in Navia. And if I can just finally go back very quickly to this, I can also add that another way of increasing the safety is to utilize the fact that we have established a wide area multilateration system in around several of the major airports, not all of them, but in many of them. So there is wide area multilateration around Aalborg, Aarhus, which is actually at the moment not intended to go remote, Billund and Roskilde, and also Copenhagen. So we know that the Frequentis Prisma system is capable of utilizing the information from the wide area multilateration system, both also including the ADSB data. So we are sort of prepared to utilize that functionality. And by this, I would like to end my presentation and say thank you for the opportunity to present ourselves and what we're working on. And then I would like to hand it over to Didi in Karlsruhe.
For the insights, for sharing the insights with us. I think it's now time to switch to the final speaker, number 4, Michael Ellinger, Product Manager for the Remote Tower Portfolio. And over to you, Michael.
Yeah, thanks, Didi, and welcome from my side, again from Vienna. So yeah, thanks, Frank, for that very nice introduction. And I think what we can see here is that this kind of approach from Naviair is really bringing that concept of remote tower to the next level, yeah, by combining remote tower together with approach services and combining this in a center. And I think Frank outlined in a very good way what is the benefit and the flexibility that you get out of this concept. Yeah. I would like to maybe give you a bit further insights on the solution itself that we are providing to Naviair, and talk about some remote tower capabilities, and then ending up with a summary. So what we basically provide to Naviair is a turnkey solution for both the remote tower part and the approach center. So this solution is based on an integrated product portfolio from Frequentis and Comsoft. Actually all these mission critical components are owned by the Frequentis group and also are managed by Frequentis. So why is this important? I think it allows us to really maintain a long life cycle of the solution, and it allows us to also upgrade and improve the solution over the time with additional capabilities. So like Frank was mentioning, a future upgrade to a multiple remote tower capability and something like that. Yeah. So the main domains that we provide, the main product domains, are information control with our smart tool products. Then we have the flight data management solution, Smart Strips. Didi introduced already the Prisma system, and the visualization, the video-based visualization is the Smart Vision product. So that's the core elements of the solution. We provide also some center management and planning tools for the supervisor position, a screen and data recording solution, and as well as a training system, including a simulator. What I would like to highlight here is that introducing remote tower is not like a standard system supply. Yeah, so it's really change process in the organization, and it's requires a special process also for delivery and implementation. And we have adapted our process in a way that we try to support our customers in all that phases. So not only providing the system, but also consulting in transition phase and in the safety area, as well as for the regulatory approval. So it's really enabling our customer to set this in operation, because that's the final goal of that endeavor, of course. Yeah, and we see one element on the slide here, quite prominent, which has the tag mosaics. Maybe you heard already in the other sessions about that. That's our ATC grade integration platform, and that's more or less the key or the heart of the solution, interconnecting all the different components and providing an integrated system to the end user. Yeah. Actually, it's not only used to interconnect the Frequentis components. It's capable of handling voice, video, surveillance data, meteorological and flight information. And it's an enabler also for our customers to share this data with other units around the airport, or to integrate, for example, third-party application. So that's really enabling our customer to make use of this data, and it's an open platform, open interfaces, where our customers can benefit from. Let me come back to the remote tower features. Didi introduced already the Prisma capabilities, so I would like to highlight a couple of features that are unique in our system. Maybe starting off with the working position. Frank already mentioned there is a lot of discussions around that. Also, the end user gets involved in this. And what we see typically in the market is the kind of video wall-based approach. But we also have an alternative for that, so that we developed together with DFS, what you can see here on the left part of the screen. So it's a more compact presentation of the console and of the working position, with an individual panorama based on 4K screens, which allows you to pan and to zoom into that relevant areas, and or present a 360-degree as a whole. And it has basically, I think, 4 times less footprint than a standard video wall-based remote tower working position. So it enables our customer to more efficiently, I think, roll out and design centers hosting multiple airports, especially for smaller scaled airports. So it's really increasing efficiency, cost efficiency in that regards. Whenever we talk about remote tower, it comes with a lot of nice features and capabilities. One of that is the bounding, the automatic highlighting of objects in the video, grabbing the controller's intention on the ground, but also in the air for highlighting small objects in the traffic pattern, for example. So our solution was introduced in operation already more than 2 years ago. It's used by DFS since that, and it's continuously improved also with latest technology like artificial intelligence, for example, to separate between misboundings from clouds and relevant objects. And I think we have a unique capability here relating back to the surveillance chain. So what we can do out of the bounding is that we are feeding that information not only to the video, we are providing that information to the surveillance processing system, to the multi-sensor data fusion component. And that allows to basically fuse together classical surveillance information with the bounding information. And as a result, we get a more accurate surveillance data feed out that we can use, for example, to be displayed as a label in the video with a much higher position accuracy. Yeah? So that's really a unique opportunity or a possibility that we can provide in this integrated approach. I will not go in details about the integration features. I think we had a very interesting session in the morning from my colleagues from the tower side, highlighting the possibilities that we have here. One word to the cameras, because remote tower is a lot about camera solutions. So we have a dedicated PTZ camera, so pan-tilt zoom camera, developed specifically for remote tower usage, including features like ICAO compliant light gun, a visual zoom camera, advanced infrared camera with zoom capability, and it supports tracking, so automatically following up objects and so on. Yeah, I think future-proofing is an important topic, and our system architecture is already prepared in a way that we support multiple airports within the same system, and therefore we are so-called multi-remote tower ready, which means that the system can be extended over the life cycle by supporting controlling of multiple airports during night shifts maybe, or then later on during day from one working position. Yeah. Let's operating, I think, a remote tower center, there is a certain motivation, and a very important factor is cost and efficient operation. And to do this efficiently, there is a lot of actually planning and management to be done in the good way. So what we did is that we analyzed the different roles and the different tasks that has to be done on the center level, and we try to derive from that a set of tools for planning and optimization, enabling our customer to be supported by that tool in their planning and management process. And the main areas that we are touching here is briefing and rostering, shift planning, but also the technical and the operational supervision, as well as traffic forecasting on a short term, but also on a long term perspective. If you have more interest in that, I would be happy to share more detailed information. By now, I will leave it to that. Yeah, let's close to the end of my presentation, and I would like to maybe summarize in some quick words what we heard so far today. So I think we started off with the surveillance chain and got a good overview from Daniel how Frequentis Comsoft can provide that in an efficient way, covering all the elements that are required from the sensor to the transition and also the processing. And then Didi introduced us more or less to Prisma with different use cases on the en route area to provide a efficient and reliable solution to use Prisma, for example, as a contingency solution for an ATM system. And yeah, the second case was then having really a new approach for provision of tower and approach services presented by Navi Air. With the main benefit Frank highlighted in terms of gaining flexibility in operation, of course, trying to reduce cost, having seamless coordination between the tower and approach service and the efficient handling of that, and even increase safety by using more advanced features in that regards. Yeah. That's the summary from my side. Maybe as a last statement, just a question: why do we think that Frequentis is the right partner for this time, for these challenging times, and for this we call it new normal? I think we are quite agile and flexible in the delivery, so we try to support and make it possible. Yeah. We have a product portfolio which is operationally proven, which is integrated, and which can be tailored to your needs. Yeah. With that, I would like to end the talk, and thanks for your attention. Getting back to Markus for some questions and answer sessions.
Yeah, thanks, Michael. Well, you summarized the talk already. So what else should I do now? Now it's really about the questions. You really put in a summary, the surveillance chain, putting that together with Prisma, and then this new approach of remote digital towers and creating a virtual solution out of this, a true virtual center. Some call this a hybrid center approach. There are many names to that, but it's awesome. And it's definitely in the future of the European air traffic management concept, but also worldwide. I think it's very beneficial in terms of efficiency. So there are a few questions, and I'm looking to the production if we can. What's the best way we can post the questions here now towards Copenhagen, and of course those who joined me in the morning. Billund is of course in Denmark, that's for sure. So there's one question regarding the training and transition from regular tower to the APP, to this hybrid APP, and I don't know, can Denmark still hear me, and can we get them to answer that? I think it's Frank, if you could answer that question, the training and the transition aspect.
You will have to repeat the question simply because I just got the audio 2 seconds ago, so I had no idea what the question was.
Okay, so I'll read the question again. How is the training and the transition from a regular to remote tower and APB done?
Well, it's today the situation in the Billund airport is that the system used for approach is actually our Top Sky system, which is also used for ACC. So the controllers in Billund are familiar with an advanced ATM system, and they are used to both working only approach, to work only tower, or both for Billund. So, and since we have of course looked at the gap between Prisma and Top Sky, and we have found that although there are differences, Prisma is a very advanced system as well, and also the HMI is highly configurable. That's at least our impression. We haven't done it yet, but the demonstrations we have seen looks like it's very flexible. So we have a great opportunity to adjust the HMI. So that the training required to go from Top Sky to Prisma could be made sort of minimized in a way. For the remote tower part, it is of course different because a lot of it is going to be new for the air traffic controllers, but luckily we have experience in Navia with electronic flight strip systems, which is part of the remote tower system. And we also the smart tools part, which is the way you control the equipment on the airport, like airport ground lightning and ILS and stuff like that, and also the source for weather information that is very similar to the system they use at the airport today. So the very new part is of course looking at screens rather than out of the window. And that is of course something where we are going to use a lot of time, and therefore we have actually decided to build an additional platform exactly for HMI design and for human factors investigations, so that we can sort of tailor it so that the air traffic controllers they feel as comfortable as possible shifting to the new technology. The fact that they will get, in our case, an infrared sort of camera, PTC, in addition to a normal PTC, is something which is new for them. And that is, of course, something which will only enhance their situational awareness. But that is where we see the sort of probably the largest training needed. That is how to sort of interact with the visual presentations. That is probably the most new. And then the electronic flight strips, we have knowledge in Navia, but not necessarily in Billund. So that will take more time.
It's an interesting approach here that you take, and I heard once that on the remote tower we take certain things away from the controller, but we give them additional tools, additional features like the infrared. That goes also hand in hand with another questions that we got to the chat, and I think I would like to address that to Michael Ellinger. So it's related to the visibility. So what happens in case of poor visibility? How does it work?
Yeah, so basically, Frank mentioned it already. I think compared to that reality, of course, we have similar constraints. The camera is capturing the same kind of visual spectrum. And if there is a heavy fog or so, you have also decreased visibility. But having new technologies such as infrared in place there as well, it can improve in certain conditions, especially during night and during certain weather conditions, the capability of seeing and feeling. And for example, the overlays, the adding the labels on top of the visual panorama would enable you, even in low visibility, if you have surveillance information, that you see where the aircraft should be on that level. So here, the remote tower and the augmentation technology brings you really some additional benefits compared to the situation that you will find in a conventional tower. And we have experienced that kind of improvement also in other projects, for example, at DFS, where they really saw that improvements when they're working from the remote position.
Okay, yeah, that's an interesting concept. I mean, like the example that you brought, where you take the visual view and fuse it with the surveillance data and make more out of it. I think that's a good example of digitalization here. So I'm looking at the time now. I think we are reaching the end of this very interesting session. I would like to thank my speakers, and especially thank you to Frank, of course, from Copenhagen, and join us here and giving these great insights. Make sure to hit the like button on this video. Make sure to subscribe to our YouTube channel. If you want to follow up on that, please get in contact with us. You can do that through our internet web page. You can contact also your Frequentis point of contact, or you can just put your contact here into the chat, and we'll make sure we follow up with that. The next session is going to start in about 2 hours. If you want to join that, the next session is about voice communications, and especially IT voice communications. If you want to join, you can use the same access code, the same access link as you are on right now. Thank you to everyone who was joining us here today. Thanks from all the people around the world that we had here in this live session. We are here streaming from Vienna. We are basically among us, but it's great that there is such a big crowd out there which is listening to us. I wish you all a great day, and hopefully I see you at the last session in 2 hours. Bye-bye.
Public Truck Signal 102.
Signal 102, confirm established.
Affirmative.
Thank you, contact tower 119 at 804, good night.
119 102, good night.
Hello viewers and welcome to the 2021 edition of Frequentis Connect, the exclusive live broadcast about Frequentis air traffic management solutions. I'm really excited to have you all here. It's the fifth session now from the day. If you're joining for the first time, I welcome you to this session. We are all excited to have you here. I'm really excited because today marks the day where we would normally be in Madrid and meet and greet and have an exchange and have conversations. Well, World ATM Congress this year is different. It's moving to October. It's going to be in Madrid, and we are really looking forward to this one. Now we are here at another Frequentis Connect session, and we are getting going with, and we're talking about digital ATM and the new normal and what that is all about. I'm just checking down below here because down below I have the chat, and I would like to look at the chat and see what's going on here. So I hope you're all doing great and you're getting excited and get involved. So it would be great if you just put in the chat where you're calling from, where you're joining from, to see who we have in the chat here and who we have in the call. The new normal. This is the topic of the day. All the 5 sessions today and also of this session now. The new normal is totally different in aviation. The traffic levels are certainly nowhere near where we all want them to be, and it's still some time ahead for this recovery. But there are certainly positive things ahead of us. For instance, the CDC in the US just recently declared that all vaccinated people can meet in private without wearing masks and also without social distancing. Or if I look at pictures that I get from friends from Australia or New Zealand, they almost have a normal life there. This is really, really great and positive news, and that's the news that we all need for the aviation recovery. So I'm seeing already in the chat, Netherlands is here, Erin, yeah, so I see that here. Great that you're still staying on here. Monica, hello. Romania, Netherlands, Oman, already getting quite late there, yeah. This is great, so I hope we can have the chat going there. The chat is important because the chat is your way to interact with us. We would like to use that for posting questions. We're going to address them in this live call after the presentations, after the talks. And if you want to comment to us without public, I mean the chat is public, so please respect that. If you want to do this not public, there is an email address which we will just post in the chat where you can send the questions, and we still gonna answer them, try to answer them at the end. But we keep the source there. So hello everybody, I see that from Salzburg. Hello Leo, Yvonne from DFS in Germany, welcome. Arturo from Mexico, Gary from Oregon. Yeah, I hope it should be not so late anymore for you. I know you were there in the previous session as well. Iceland, great. Romaca, Romania actually, one from Monica. Hello Monica, this is great. Hi. Hi all. So let's get going. Today we have two speakers, and we're going to speak about IT, and we're going to speak about voice communication and how that actually is going together. The two speakers I have is Alex Neuhaus, Strategic Product Manager for the voice communication system, and also Martin van der Lee. And without further ado, I would like to hand over to Martin. And I hope you're doing good. Martin, over to you.
Your elaborate introduction. And I hope everybody can hear me. It's the new normal, and the new normal means that we're not at the same location. In Austria, we say that there's a small elephant in between the people. In my case, it's a little bit more. So I'm actually in another part of the office. And I'm going to do a presentation from here on our ATM voice IT product. Let me guide you to what we're going to do today, and I hope that's going to be very interesting. The first thing we're going to do is to tell you a little bit about our strategic idea behind VCS, Voice Communication System Future. Then we'll tell you a little bit about the solution, what our implementation is, and then we do a demonstration together with Alex Neuhaus, who was already introduced by Marcus. And actually, Alex Neuhaus is in the room where I'm virtually in. You see in my background, which is a fake, the picture of the demonstration room, and we'll actually go there and have a demonstration of our VCS system. And at the end of the demonstration, we'll do a question and answer session. So without further ado, let's dig into it. I introduced the IT of VCS, and why is it interesting? From today's challenges, flexibility, and I think especially during these times, as Marcus introduced, there are people that are almost living a normal life, whilst here in Austria, we have to stay home and you can't go out in the evening. So it's really hard to predict how things are going to evolve, yeah, and they are totally different in different parts of the world. We need to be flexible, yeah. So we also need our systems to be flexible to adapt to whatever, let's say, resurrection of the ATM market will come and how it will come. Next to that, obviously, things that were happening before COVID don't go away. We still have a large legacy, a technology legacy, an end of life of those elements, and especially related to voice, that was always in conjunction with the transition to voice over IP. And I think that it's still an ongoing theme, yeah. And I think next to that also the transition from bespoke and proprietary technology to IT systems is something which will help and is also in the mind of ANSPs around the globe. And last but not least, what we also see is a change in the concept of operation, and that actually relates to the scenarios which are introduced in on the right side of this slide. Let me show that with the laser pointer, where we have new scenarios like the virtual center operation, collaborative ATM, people working together on different locations, but working with the same airspace, and also the team of contingency. So what do we do in case something really happens? And actually, these are part of the ATM master plan and the ATM master plan targets. So from the outside, we see these things happening. What does that mean? Obviously, looking at the total cost of ownership, managing the legacy of the technology, enabling operational flexibility, yeah, being able to, for instance, operate a piece of airspace while you're not directly sitting under it, so moving sector responsibility between air traffic management service units, these kinds of things. And then I mentioned the word IT, and I think everybody knows and is aware that if you run an IT system, you have to think about IT security. So I'll also spend a few words about that today. How are we dealing with IT security in our IT VCS, and how do we make our system operational, secure? And last but not least, especially related to VCS, yeah, sort of the pillar of one of the pillars of the ATM system. It's always expected that our systems are safe and reliable. And whatever we do to our system, it doesn't go away. It's the basic expectations, and I will also explain what do we do there to keep on providing a safe and reliable system. Looking further into this paradigm of moving to IT systems, what does that mean to the triad of people, procedures, and equipment? Those are the things when you change things in your environment, these things may be affected, and actually we don't want them to be affected very much. We want only benefits. So for people, when moving to an IT VCS system, keep the workflow, the skill set, and the training. It's just like any other IT system you have on your premises. So when you look, for instance, in your equipment room, you see the silos of technology, and I will tell you a little bit more about those silos a little bit later on, like pillars that are standing next to each other, where the FTPS system, the voice comm system, and next to that even maybe a smart strip system, and they have nothing to do with each other. And we want to dissolve those silos and also manage this voice communication system, which used to be something special, like any other stack of servers you own and run. And also therefore have the same maintenance procedures, and same operational procedures, so that there is it's still a VCS, a simple and easy learning curve, both for the air traffic controllers, but also for the air traffic system engineering personnel. And obviously the equipment, we are now stepping away from having a appliance, something which is specifically linked to a piece of hardware, to something which can run anywhere. And I know this has been told by many companies before, but this is actually truly something we deliver also in the way we virtualize the operation of our system. It's just another IT application running in your IT environment. And you may wonder, why am I talking about this and why does Frequentis do these things? It's actually related to what is going on in the Single European Sky research. And I took this picture from the European architecture study, and because it beautifully shows the concept. On top we see over here the airspace users, and then the air traffic service providers, the ANSPs of the world, providing the service, so that the air navigation service, so that the people can fly. And below that, that's where we are, the data and application services, which then use the infrastructure, the radio infrastructure, the telephone infrastructure. And we see in this model that these are actually separated. The separation between the service providing to the airspace user and the service provision of voice communication services to the ANSPs. And this model is actually shown in the silo diagram, dissolving the data silo, so coming away from the comm silo, the EFD silo, the surveillance silo, and integrate that into a service provision, so that we also, the silos which actually extend to the desk of the controller with the different displays, enable also a more integrated and harmonized way of working with an integrated controller working position. And this idea is driven obviously by the ideas of the European ATM Master Plan, as shown in the slide before, but also by the idea of harmonizing the technology you need to provide these services in an IT system. So what does that look like? What is our solution when looking to that? Boiled down to a voice communication system. Looking at the architecture, we introduced new elements, the data center, where the voice aeronautical data service provider is hosted in the middle. And then we have the air traffic service units, as I've shown in the picture before from Cesar, where the air traffic controllers are, and they can use services from the data center, access the radio network, where we have frequency services that are actually providing the function of the frequency towards the data center. And obviously you could have a second data center which is separated, where another ATSU is providing services. And then the beauty or the magic actually happens, the benefit, when you combine them. Suddenly you have a duplicated data center access. So you solve the challenge, for instance, of what happens if something breaks. So if, for instance, this data center over here breaks down, you can immediately switch over to the data center over here and still use the frequencies as if they were, still your frequency and hosted the same. But also you can basically share or take over the responsibility for a piece of airspace, because this ATSU would have access to all the frequencies below. So basically you can talk to the airplanes in a certain sector just by sharing via the frequency service. And the beauty of the frequency service is you don't even need to know or have to own the radio infrastructure, which is obviously located under the airspace which you are servicing, because the frequency service itself abstracts everything from main standby, delay compensation, best signal selection, everything which belongs to the operation of the frequency to the air traffic controller, so that this frequency actually works and shows on the HMI just the way they are used to in their everyday work, regardless of what sector they are operating. So with such a model, we can achieve the virtual center goals. Flexible sector allocation, access to frequencies from anywhere, cross-center sector delegation, moving responsibility, and also contingency. So what happens if something fails? We could have what we call a non-cooperative ATSU takeover, where another ATSU takes over the work of one of the other ATSUs. If there's maybe an earthquake or whatever, this ATSU cannot work anymore, somebody else in another location can take over. So this model, how do we do that for our voice communication system? Separating here on a horizontal level the ATSU side, the data center side, and the frequency service and telephone access side. We do that with our IT system for voice communication, separating the operation center from the data center. And we do that with our VCS, with introducing some new stuff on the operation center side. On the HMI, we have our context-sensitive GUI, and we'll actually show and demonstrate that. So I'm building up already the excitement for that for you on what Alex is going to show, with a touch-sensitive display, which actually uses the same technology which you are used to from everyday smartphones. And we also introduce what we call HD audio, so a wideband audio for better, excellent speech quality. And in the data center, we use something new. The data center, as I said before, actually independent, could even be your IT hardware. It's still based on redundancy to keep our availability high, to keep the safety as high as you are used to from a Frequentis system. And we do that by introducing a new platform. And this platform is called Mosaics. This is a new term. I'll briefly introduce that as it is something new. And Mosaics is the Frequentis platform for application integration. So we see different applications which can run on this Mosaics platform and which actually then integrate both from the operational perspective, how you configure them and how they work together with their mission management, role allocation, but also how they work together on the HMI side. That is one benefit of the Mosaics platform, but also it's bringing the availability of the IT world and the safety regulations of the ATM world together. So with Mosaics, we build and sort of bring the glue between what is available in the IT world and what is well known in the ATM world, bring IT, security, performance, and safety together. And this is our, let's say, Frequentis add-on, which we call the Mosaics Digital ATM platform. So only a few words about that. I think it's a very important step forward where voice communication is one of the first applications running on this Mosaics platform, with many more to follow. A few more words about redundancy and availability, and I think this is really a key point. The system is based around a fully duplicated and parallel audio transmission, so that if there's any outage somewhere in the between the different endpoints, we actually have an unnoticeable switchover because there are two paths from the CWP to the radio, actually based on standard, so it's working with DD137 B and C radio equipment. And within these two paths, you could have two separate networks. There are two separate hosts which are calculating the same thing at the same time. So they are doing the same thing, so that if there's an outage somewhere, directly always on the path, there's always a speech packet available, which you can hear or talk, which makes the system extremely robust against outages, and basically always provides seamless audio. Second thing we provide in our system is a special take on bandwidth management. So if we are separating the data center from the control room and also from the radio sites, it is very beneficial to look at the bandwidth you are using. What you don't want is to have a very unpredictable traffic characteristic on the WAN over here. You actually want to know what's happening. If you suddenly need more access to frequencies, you don't want to run into bandwidth problems. So we introduce a true data center approach here with a thin client CWP. So we have very slim connections between the CWP in the control room and the CWP service, where the whole logic is residing in the data center, so that we don't have any unpredictable or excessive bandwidth usage. And actually, it doesn't matter how many frequencies you are operating on the panel. It could be 2 or 24. You're always only transmitting bandwidth-wise what you want to hear and what you are saying. And the same goes for the other side. When you connect to the radio, there are only individual bandwidth needs and sessions needed between the frequency service and the radio, only one. Yeah? And all the mesh of who wants to hear what is actually happening within the data center, where both calculation power and bandwidth don't have any additional costs, and also has no real limitations. So the whole complexity of the system resides in the data center, where it doesn't provide any problem while operating. I also promised that we would talk a little bit about security when you talk about IT systems. And let me first tell you a little bit about what security actually means in a voice communication system. Voice communication systems are special from a security perspective. Most IT security is based around the concept of client-server and very well-known communication matrix. So there is some client application that contacts the server with a certain data model, certain protocols and data model, and it makes it all extremely predictable. A voice communication system is about communication. It's simply said, I want to call you, maybe you want to call me. So we need to cater and facilitate for that in a little bit in a different way. Yeah? It's no longer a simple client-server approach. And therefore, we use defense in depth approach. Defense in depth is not something which we came up with. It's the state-of-the-art in data center security. And you may want to compare that with, let's say, the medieval castles, where you would have water between water surrounding around the castle. You would have a high wall and maybe somebody standing on the wall. Those are all different layers of security. And if we bring that to our use case, we have different zones. We have the trusted zone. The trusted zone is where I know everybody and everything which is running in this zone. Yeah? And so you have to create this trust on a technical level. So we do that by authenticating all the applications, all the different hosts in the system. Against the domain controller. Nothing new, it's not revolutionary. I think that's the state of the art in the IT. And this also comes inside the box of the VCS. So it even has security inside the trusted zone. Then we have something which we call the shared zone. Shared zone is typically something you would need for a telephone call. You may want to talk with your neighbor. You like your neighbor, but do you want to put the whole trust of your security in the responsibility of your neighbor? Maybe not. Yeah? So there we have the session border controller as a standardized element, which basically gives you the authentication and the access for people outside of your trusted zone. And then we have something which we call the public zone, where basically you may want to travel to, but through with your data or with your connections, but you want to protect yourself against any outside interventions. Yeah? And this model we call the data center security model. So this fits into the environment, aligning with the IT implementation, our domain controller, which comes inside of our voice communication package, actually can interrelate also with your domain controller. It doesn't need to have a separate domain. You can manage that from your security operations center. It's not something obscure or proprietary boxes. It's completely along the lines of state-of-the-art security. And what also comes with state-of-the-art security is a life cycle. It's well known, and I think everybody has read about the exchange security labs that's currently happening everywhere. Yeah, you need sometimes to patch quickly. Yeah, our model and how we build software is built around what we call microservices. So they're all small services, and if there's something affected, it's even possible to only update a very small part of the system, which makes the safety side very simple. The safety side of assuring that it is still working, doing the regression testing, etc., so that we can actually support a security lifecycle which is both IT conform but also operational technology conform. This was all like theoretical, but what does it look like in our system? In our system, again, yeah, the operation center, the data center, the radio sites, yeah, we have different services which are running there, our microservices. And the first layer of security, the first boundary, comparable again with the water around the castle, is the public to get the public zone down. Protection by VPN tunneling, encryption and firewalls. Standard IT equipment, standard way of doing. Yeah. Then the second layer, introduce the session border controller, yeah, to have access for dynamic connections like ground-ground, which are both incoming and outgoing. And last but not least, the Mosaics domain controller, yeah, again, something from our Mosaics platform. The domain controller, which comes with the platform itself, where every host and every service authenticates against the domain controller, so that also on the operational system, no, let's say, unauthenticated software or virus software can actually start to run on a system without us knowing it, or basically you knowing it. Yeah. So those were a few words about security. I think a very important topic. And now we go further towards the demonstration, and let me first set the scene for Alex, and that works with the HMI, yeah? And let me introduce how that works. We have introduced something really new and I think pretty cool. Yeah, we can actually now let you freely configure what the HMI look like. Yeah, and we do that with the Mosaics configurator. It's actually a web-based configurator, and we build the HMI around the concept of the grid. You may wonder, what is the grid? You're working with the grid every day if you use a smartphone. On phones like this, you have a grid where all the applications are. Yeah, so some designer somewhere at Apple in this case has designed the size of the grid and where the applications are. Our idea is the same, with that difference that you can also design the size of the grid, and that every button and every function there is on the HMI is actually a small widget, like you are used to on a smartphone. So you can drag and drop your keys, your function buttons, just in a simple design way on this grid. Yeah? You can also add the functions, function keys, yeah, which function should be somewhere. Yeah? And there are things like subgrids and clones to make this HMI completely flexible, to have your DA pages, your radio pages, to come to a result which may look like this. I won't go into much detail on that. I think that is something for Alex to show, to have a peek at the system. And therefore we go to the room I'm virtually in, the demo room, and which you are seeing now. And with that, I hand over to Alex to do the demonstration.
Thank you very much, Martin. Hello and welcome to the aviation studio. This is real. Everything is real physics in here. we will use two working positions, number 1 and number 2. And to demonstrate it much better for you, I will use a really large touch screen in the other side of the room. I totally love it. Please come with me and I will show it to you. So here we are. I have mirrored those two working positions from over there, from the other side of the room. Here's one, here's the second one. Now let me quickly introduce you what we are talking about. So this is a typical panel for an ATCO. And in this configuration, I have a status bar on top, I have my time, I have my connection status, I have the role, I have the working position number. And in this case, I really have a large area of the screen for the direct access keys. On the left side, we have just 3 frequencies. And as Martin explained, we're really free to use any space we have for the screen. So we can make this bigger, smaller, we can move it up, left, down, absolute freedom. In this case, we have on the bottom, we have our function keys placed. We have our call queue on the right side. And we have more tabs configured, so we can use more direct access keys than only seen on the first page. Let me start with a simple interaction of a controller. So we have used capacitive touch technology for this use. You all know that from the smartphones, as Martin already showed. By the way, Martin, I like your background from the smartphone, really fancy. In this case, I want to use, let's say, 2 or 3 frequencies, and there is a meaning behind these gestures we are using. In my case, I swipe down. I want to receive something, so it goes into RX state, so this frequency. If I want to transmit, I want to send out something to the outside world, I swipe out because I want to transmit, and in this case, it's already keyed in. Maybe you have also recognized on the second position, of course, you have the indication by other. So this controller knows that someone else is monitoring the second frequency and has the first frequency in traffic mode. Now let's switch to a very simple use case for ground-ground communication between those 2 positions. I have configured my direct access keys here. Second position is over there. What happened? I have pressed the direct access key. You hear the ringtone, hopefully from the other side of the room. This position received an incoming call. I have accepted it, and now I have established an audio connection between those positions. Let me repeat this once more. I just press this button. I take it over and have my active call. Now, what we have introduced here is a very nice thing, because the controller is no longer forced to look away from the object he wants to deal with. In our case right now, it's the active call. If I want to interact with this here, we have introduced context-specific menus. When I swipe out of this active call, I see the options I can do or interact with this active call. I take the simplest one, I just put it on hold. Of course, the other operator gets the indication, okay, I'm put on hold right now. As easy as that, I just click it and the call comes back. Now, if the eyes from the operator are sticked to the direct access key from where he initiated the call, same story applies. I can swipe out, I get my options over here, I place it on hold, I see the indication here, I see the indication over there, and of course, the second operator sees the same story. And again, I have used the origin from the call, and if I press it, it also gets to be or is an active call again. So that's a pretty easy one. If you want to use different direct access keys, let me just finish this call. If you want to use different direct access keys and you say, well, that's a little bit grayish, can you bring in some more colors? Of course we can do. You can freely configure on your own all the colors you want to have. So, and of course we can group them together. So here is the blue area, here is our so-called search and rescue red. You can figure it as you like. What else you can do with the flexibility of the HMI? You can create so-called customizable pop-ups, and they can have every size, and they can contain every widget, what Martin explained we have in the system. So maybe you have not recognized in this layout that besides all these direct access keys, I have created another one here. And if I press this one, it opens up a subpage, a customizable pop-up with, again, 9 different direct access keys. And of course, I can change them in size and colors and whatever. If I press it again, I have my active call, as you, of course, would have expected. So with this little introduction, let me ask Martin to reconfigure this layout a little bit while I show you another use case in the background. But of course, you can take your stopwatch and have a look how long it takes for Martin to change that. So what I did not like in this layout was that we have placed the call history up here. I really like it down here. Then Martin, if you please be so kind and change this direct access key, because I have used it so often, can you please make it bigger and give it a color? And then I don't have used this frequency at all, so please remove that. While Martin is doing that, I want to show you a specific functionality we have and which comes from the architecture. So when I change my mission right now, and that could happen pretty often, especially when we think about future use cases from the virtual center, you will use those mission changes a lot. What we can do is the following. I change the mission now to a tower layout. Yeah, it's just another layout, let's say. Yeah, it's not super specific for a tower. But what happened in the background, the call was active all the time during my mission change, and also the frequency I've set into traffic mode was also active all the time. And all the communication, I could participate. I could even press PTT and talk to the pilot while I changed the mission. Now let's switch back to my original mission. And in the meantime, hopefully, Martin has already changed the configuration for that. And he did. And the funny thing is, so he removed the frequency, he put down the call history. Thanks for that, although that's a little bit larger than I wanted, but that's fine. And the call was still active. Now, if I close the call here, you also see that Martin has changed the color set for that. And this is really a nice feature we have in the end. So with this, I would like to hand over back to Martin, and let's continue him with the presentation.
Thank you very much for Alex for the for your presentation, and yeah, I think it was pretty nice, pretty impressive what we can do there. Yeah, so let me wrap that up, yeah, and tell you basically what we think and how we see this evolving. With the IT software future, we see the three major elements: the architecture, the hardware, and also the delivery in both the life cycle. On the architecture side, we bring you a true IP system built around the latest ED137C standards. That's a fairly new standard. ED137C has been released completely last year, and already in our system today. It integrates in your data center. We actually also prove that and retest it every time, as we also test and operate our systems against different hardware types. Yeah? And it also integrates with your network and security infrastructure. As for all these redundancy things, which also Alex has shown and I've shown in the beginning with the parallel audio, we don't need any specific or special implementations from the network. We just need a VoIP-compatible performance. And it's future-proof. Yeah? It's cloud-enabled, built for the data center approach. Yeah? Fits into a data center model with our service-oriented and software container structure. Completely independent from the underlying hardware. You can even use your own. Yeah, I know that it's used too in our domain that there's sort of the turnkey deployment where we provide everything in big racks. That is actually no longer needed. If you have your own hardware or your own data center, that is perfectly fine. It's a true software solution. And I want to introduce something new, the evergreen software model. I mentioned that in the context of security, keep the software up to date, but even beyond that, always own a new system. So also get the security fixes, get the security patches, but also benefit from the VCS product roadmap and the influences of all the Frequentis customers as part of this evergreen model of keeping the software not only alive, but keep it new every day. Imagine that you would have, after 10 years of operation, still a system which is new and has the latest software. As you may know also from other software providers, so that's such a thing of a new investment is no longer really something which you need. To round that off, what have I told you? The evergreen life cycle, keeping the system new every day, get away from this trap of owning old technology and support the security life cycle. The virtual center, any frequency, any controller from any location, separating the control room, the data center, and the radio infrastructure. Duplicated and parallel running audio with a seamless switchover. Something which truly benefits to the robustness and the safety of the system. The integration with ATM system, the Open Mosaic software framework. Minimal bandwidth usage, where we have, remember, from the CWP to the data center, precise traffic load, predictable traffic load, what you say and what you hear, and also from the data center to the radio, only one link. And last, but definitely not least, we put the users back in focus again, the people. Fully flexible configuration, context-sensitive interactions with Alex Action, online reconfiguration, quick, flexible, intuitive. And you can design it any way you like. It's not that we give you a design, you design what you want, and it's supported only by configuration within our product. With that, I would like to thank you for your attention and hand over to any questions we have. Marcus, any questions from the chat or from the round?
Pretty cool things here. Yeah, I got two questions, one from the email and one that is in the chat. So I would like to start with the question from the chat first from Yvonne. Thank you for that. Great, I appreciate that a lot. Do you have plans to integrate data link messages into your mosaics?
Well, yes. It's a good question. Specifically to voice, I don't think that there's a real application for data link, but beyond what I told before, beyond the voice applications, we see other applications on the Mosaics platform, for instance, like electronic flight strip, where it makes a lot of sense to do so. So I'm fairly sure that within the foreseeable future, we see all the different interfaces you need for your operation coming into the Mosaics platform.
Okay. There's another question, and that's actually an interesting one. It relates to Navy or Marines, but let's see if Martin, if you can answer this one. Have field tests on floating platforms, ships, with digital VCSs already been executed? And if so, what were the results on performance with limited bandwidth?
It's an interesting one. So field tests on platforms, on floating platforms, we haven't done yet.
Well, I think of the US.
When it comes to limited bandwidth, actually the idea of what I told before, the predictable bandwidth, gives you exactly the benefit you need. You can already, without even knowing the actual traffic pattern, give a very precise and exact forecast of the bandwidth you need to operate the system, because it's not dependent on the load you have on the system.
Okay. And Erwin, I think that's a really interesting question. Let us get back to you and discuss that. One product that we have fielded is applied in the SATC program in the US on the ship carriers. So that's a floating platform there, of course. There's one question that was coming from email, and that relates to the open standards. So that's also, I think, for you, Martin. Are there any open standards being developed for the decoupling of the control room from the data center?
Yeah. Thank you for the question, Marcus. I seem to get all of them. When it comes to standardization, we see this virtualization, this virtual center endeavor, which I mentioned before, has gotten some traction also to the European architecture study. And there's now a working group being established, or actually is already established inside of EuroK, the working group 122, where we also decided to take part to get more standardization between the ADSP, the ATSP, and also for the virtual center concept as a whole. So keep your eyes open, and also for what's coming there. That standardization effort is already on the way.
Okay, great. So I think that's it. No more questions yet from email, and no more questions in the chat. I think we're coming to an end of this session. Thanks to my great speakers. Thanks to Alex. Thanks to you, Martin. That was an interesting and amazing update. For you viewers out there, thanks for joining us for this session. It's been a great day for us. 5 sessions of Frequentis Connect 21. I'm sure we're going to repeat that soon. If you liked what you've seen, what you heard, make sure to hit the like button, subscribe to our YouTube channel. If you want to get in contact with us, send us an email through invitation@frequentis.com or the website frequentis.com, or you can also contact us through your local Frequentis contact person. That's it from me today. I can only wish you a nice day. Have a great day, have a great evening, have a great rest of your day, wherever you are. Thanks for being with us. Goodbye.